Yeah, hi everyone, welcome to PrepFusion. So we have completed vector differential calculus, right? Now we are going to start vector integral calculus. So before that, let's revise a few things. Do you remember what is the meaning of open line? Open line. Do you remember what is the meaning of open line? Absolutely, sir. We need to go from A to B without coming from from B to A. Okay, this was your open line. Do you remember the meaning of a closed line? Absolutely, sir. Clearly, sir, I remember the meaning of closed line as well. I went from A to B, then B to C, then C to D, then again D to A. This is a closed line. Sir, it will be enclosing some area, but there will be no material inside. A to B, sir, B to C, C to D, and D to A again. What kind of rotation it is? Clockwise, right? It is known as clockwise rotation. So this is your closed line. Do you remember? Do you remember the open surface? Do you remember the open surface? Absolutely, sir. I remember the open surface as well. This was my open surface. It is not enclosing any volume. It is simply a surface which is having some material here. And do you remember the closed surface? Absolutely, sir. I remember the closed surface as well. It will be enclosing some volume. So using the open surfaces, we make the closed surfaces, enclosing some volumes. Right? This is your closed surface. Do you remember the small length? Do you remember the small length dl in Cartesian coordinate system? So that would be dx I cap plus dy j cap plus dz k cap. So all the basic prerequisites we have already seen. Okay, these basic prerequisites we have already seen. And surface area could be dx dy az cap. All the surface area also we have seen. So now we will get started with the problem only. Directly we will get started with the problems. But do you remember the formula of work in class 12 physics? Have you studied the formula of work? What was work? Sir, if you are applying a force F, if there is some force F, then to move from point A to point B, to move from point A to point B, how much work you need to do? Like if there is a force field which is F, now in this field you need to move from point A to point B. How much work you will have to do? So that was F. I will take a small length here. Let us say that length is dr, and then I will integrate it from A to B. This was the formula of work, right? There was a field F. There was a field F. You need to move in the presence of field F. You need to move from point A to point B. What you will do? What is your path? Let us say this is my path. So in this path, sir, I will take a small length dl. I need to go from point A to point B. From A to B, I will take a small length dr and I will integrate it in this manner. This was your work. Do you remember the potential? Do you remember what was potential? V equals to E dot dl. In the presence of electric field, what will be the potential difference between 2 points VBA, VB minus VA? What will be the potential difference? This is VA, this is VB. So VB minus VA, what will be VB minus VA? Minus of A to B E dot dl. So these things are known as line integral. So what kind of question will be asked in the examination hall? The question that will be asked in the examination hall will be like this: that there is a field A. So there is some vector field A. There is some vector field A here. There is some vector field A present. Here in this 3D coordinate system, this 2x plus y I cap plus y plus z j cap plus 3x minus z k cap. So you can make this vector field. No, so this vector field is present. It could be somewhat like this. Now in this field you need to rotate. In this field you need to rotate, or you can say in this field you need to move. You need to move along the curve 0, 0, 1 to 0, 0, 0 to 0, 1, 0 to 1, 0, 0. And when you move along the curve, what is the value of A dot dl integral? This is what you are supposed to calculate. Now what this would represent, it may represent potential difference, it may represent work, it may represent something else as well that we don't know. But our target is that in the presence of this field A, in the presence of this field A, you need to move along this curve. You need to move along this curve. So what will be the value of A dot dl integral? This is what you are supposed to find out. Okay, so let me erase these diagrams and all, but I hope you would have understood the meaning of A dot dl here. So what you are supposed to calculate? You are supposed to calculate A dot dl in the Cartesian coordinate system. You need to move from this is, let's just say this is point A, this is point B, this is point C. Okay, A is the coordinate system only, no? So let's take this is P. A is the vector only, so let's take point P, Q, R, S. So you need to move from P to Q, Q to R, R to S. So from P to S you need to go. P to S you need to go. Is it open line or closed line? Is it an open line or closed line? You tell me the path. Is it an open line or closed line? It is open line only. So that's why there is no circle like this. If it is closed line, then I will put a circle here. If it is open line, then I will not put a circle. So I need to go from P to S and I need to calculate A dot dl. So can I write it down in this manner that first I will go from P to Q, A dot dl. Then I will go from Q to R, A dot dl. And then I will go from R to S, A dot dl. R to S, A dot dl. Say yes or no. Now since you are moving in Cartesian coordinate system, what is the value of your dl? What is the value of dl? So value of dl is nothing but dx I cap, because in Cartesian coordinate system move in the direction of x dx I cap plus dy j cap plus dz k cap. This is the value. So can you find out the value of A dot dl first? Can you find out the value of A dot dl? Sir, A dot dl, this is your A dot dl. So your A dot dl would be 2x plus y dx plus y plus z dy. Simply A dot dl you need to do. I cap multiply with I cap, 2x plus y dot dx plus y plus z dot dy plus 3x minus z dx. So basically you are supposed to calculate this integral. That's it. This integral you are supposed to calculate. This is your question. So let's go path by path. Let's go from P to Q first. First what we are doing, we are going from P to Q. A dot dl we are supposed to calculate. A dot dl we are supposed to calculate. That means from P to Q, this is something that we are supposed to calculate. This is something that we are supposed to calculate. This is dx dy dz actually. This is your dz here, dz here. Okay, this is what we are supposed to calculate. Now when I am moving from P to Q, what is my P to Q? Sir, this is your P to Q. This is how P to Q looks like. From P to Q, this is your point P, this is your point Q. Point P is 0, 0, 1, 0, 0, 1, and point Q is 0, 0, 0. Now you let me know, when you are moving from P to Q, what is the value of your x? Sir, always x is 0. No? Always x is 0. Always x is always 0. X is always 0. Here also it is 0. Here also it is 0. Are you moving in the direction of x? No, I am not even moving in the direction of x. What about your y? Sir, y is also always 0. You are not even moving in the direction of y. Sir, you are only moving in the direction of z. You are only moving in the direction of z. Sir, what you are doing with respect to z? Sir, with respect to z, I am going from 1 to 0. So z is going from 1 to 0. So x is always constant here. X is always constant. That means dx is 0. Y is always constant. What does that mean? Dy is 0. What does dx represent? Change in x. Is there any change in x? No. Is there any change in y? No. What about dz? Yes, sir. Z is changing. Z is changing, sir. Z is changing. Z is changing. That means, sir, dz would be non-zero. On this line, sir, from P to Q, sir, x is always 0, y is always 0, dx is always 0, dy is always 0, only dz would be non-zero and z would be changing. So what does that mean? That, sir, this will come out to be 0, this will also come out to be 0, this would be non-zero. Along with that, sir, x is also 0, this x is also 0. So this integral from P to Q, which was A dot dl, can it be replaced somewhat like this? That it will be only replaced with that, sir, I am going from P to Q, x is also 0, no? 3 on this line PQ, what is the value of x? That is 0 only, so put 0 here, minus z dz. And what is the, now I am supposed to put the limit of z. So what is the limit of z? For z you are going from 1 to 0. So z is going from 1 to 0. So minus z dz. What is the answer you will be getting? Minus z square by 2 from 1 to 0. Then the answer would come out to be plus 1 by 2. So the first answer we have got here, that is coming out to be 1 by 2. From P to Q, A dot dl is coming out to be 1 by 2. So here again I am writing down from P to Q, A dot dl is coming out to be 1 by 2, keeping in a box. Okay. Another method would be there. Another method I am writing down for calculating this particular scenario. There could be another method. Another method. What could be the another method? Another method would be by writing the equation of the line. What you can do, you can write down the equation of the line. What line we are having? Sir, we are having this line. No, this again I am drawing this PQ line. We are having this line. Sir, can I write down the equation of this line? From P to Q I need to write down the equation. So this point will be x1 comma y1 comma z1. This point will be x2 comma y2 comma z2. So what will be the equation? Sir, x minus x1 upon x2 minus x1. 0 minus 0 will be 0. Y minus y1 upon y2 minus y1. Z minus z1 upon z2 minus z1. Look, x minus x1 which is 0, 0 minus 0, because P to Q you are going, no, this is the equation P to Q. So this is your x1, this is your y1, this is your z1, this is your x2, this is your y2, this is your z2. So x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. Okay, and equate it to some t. So from here what you are getting? From this particular equation what you are getting? If I just copy this equation on the next page, what I will be getting? From here I am getting is, I am equating all of them to one variable because I want all the values in one variable only. So x minus 0 divided by 0, x divided by 0 equals to t. So from here x equals to 0 you are getting. Next, y minus 0 divided by 0 equals to t. So from here you are getting y equals to 0. And next, z minus 1 divided by minus 1 equals to t. So z equals to 1 minus t you are getting. So this is the scenario that you are getting, that sir, x equals to 0, y equals to 0 and z equals to 1 minus t. And from where to where your t is going? Can you let me know? Sir, my z is going from 0 to 1. Z is going from 0 to 1. Oh, sorry. Z is going from 1 to 0. 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 In place of z, if I put 1 minus t, 1 minus t. So from where to where t will go? T, from here if you can solve it, you would get to know that t will go from 0 to 1. Because if t is 0, then z will be 1. If t is 1, then z will be 0. Basically, if z is 1, then t will be equals to 0. And if z is 0, then t will be equals to 1. So z is going from 1 to 0, then t is going from 0 to 1. That's it. So t is going from 0 to 1. So value of t is between 0 to 1. Or better, I should write down that t will move from 0 to 1. T will move from 0 to 1. So x equals to 0, y equals to 0, z equals to 1 minus t I have written. From here, what I can write down? Dx equals to 0, dy equals to 0 and dz equals to minus dt. So now everything would come in terms of t, and the limit of t also I am having. So this I am supposed to calculate. Dx is 0, dy is 0, x also 0, x equals to 0 only, x equals to 0. So what is the value of z here? The value of z I will put as 1 minus t. So what I am supposed to calculate? P to q a dot dl. P to q a dot dl. So a dot dl is 3x minus z dz. So minus z, what is the value of minus z? Plus z is 1 minus t. So minus z would become t minus 1. What is the value of dz? What is the value of dz? Value of dz is dt. Value of dz is minus dt, sorry. Value of dz is minus dt. Now you are supposed to put up the limit of t only. So what is the limit of t? Limit of t is 0 to 1. T is going from 0 to 1. This minus sign I can go, minus sign can go here. 1 minus t dot dt. I hope you are able to understand. Here z equals to 1 minus t. I need to put another minus sign was there, and dz was also equals to minus dt. So another sign was there. So minus minus got cancelled out. So this is the scenario that I am getting, and t is actually going from 0 to 1. If z is going from 1 to 0, t is going from 0 to 1. So t is going from 0 to 1. I am supposed to solve this particular integral. What is the answer I will get? From 0 to 1, the same answer I am getting, that is 1 by 2. So the bottom line is that from P to Q, A dot dl is coming out to be 1 by 2. Different methods we can use, but this is the best possible method that we have. Which is the best possible method? Here it will be very easy. Although as of now we are taking so much of time, but in the examination, do you really think I will take so much of time? I will directly see, okay, this vector field is there, dx, dy, dz. Here only z is changing, so only dz would come into action. Directly I will be able to write down the answer 1 by 2 within one line. Although here a lot of pages we are filling so that you actually get the feel of the question. But in the examination hall, it will not take so much of time and it will not take so much of space as well, right? But here we will see different methods. Now we need to go from Q to R. Q to R, A dot dl we are supposed to calculate. This is our target now. This is something we need to calculate. So again the same thing we need to calculate. Again the same thing we are supposed to calculate, that this vector field I need to take into action. What is the value of A dot dl? Arey yaar. The value of A dot dl is already something that we already have. This is what we are supposed to calculate, and we need to move from, this time we need to move from Q to R. Now when you are moving from Q to R, what is your Q to R? Let's draw the line. So Q to R is somewhat like this. Q to R. What is the coordinate of R? 0, 1, 0, right? 0, 1, 0. 0, 1, 0. 0, 0, 0. Clearly you can see that, sir, x is always 0. Sir, y is changing from 0 to 1, and sir, z is always 0. So sir, dx will come out to be 0 only. Sir, dz will also come out to be 0 only, but sir, dy will come out to be non-zero. So sir, this term would be gone. This term would also be gone. Here the scenario would be that z will be replaced as 0. So what you will be left with? Sir, y dy. Y dy. This is what I will be left with. You are going from Q to R. What does that mean? That means, sir, y is going from 0 to 1. Y is going from 0 to 1. What is the answer you will get? Y square by 2. That means 1 by 2. This integral you will solve. Answer is 1 by 2. That means when you are going from Q to R, A dot dl is coming out to be 1 by 2 only. Okay. Another method, if you want to check, what is the another method? Another method, you can write down the equation. You can write down the equation of the line. What will be the equation of the line? Again, sir, from here I can write down x minus x1 upon x2 minus x1, y minus y1 upon y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1. You equate it to another variable which is t. All of them will be equated to another variable which will be t. So x minus 0 equals to t, x equals to 0 only. Z minus 0 divided by z equals to t, z equals to 0 only. Y minus 0 divided by 1, that means y by 1 equals to t, that means y equals to t only. So if y is going from 0 to 1, you know that y is going from 0 to 1. Since y equals to t, so t will also go from 0 to 1 only. And what will be the value of dy? From here you can directly see that value of dy equals to dt only. Value of dy is nothing but dt. Okay, so that's it. We are supposed to calculate the integral from Q to R. You know that, sir, from here x equals to 0, z equals to 0, always constant. So I already know that, sir, dx will be 0, dz will also be 0, and z will also be equals to 0. In place of y I need to replace t, and in place of dy I need to replace dt. Limit is going from, limit of t is going from 0 to 1. That's it. Job done. What is the answer you will be getting? T square by 2. Answer will be 1 by 2 only. The same answer you are getting. So from Q to R you are getting 1 by 2. Now next we need to calculate from R to S. From R to S. Our next target is from R to S. A dot dl. Again the same scenario. From R to S. Again the same thing we are supposed to calculate. Now when you are moving from R to S, what kind of line you are having? Let's draw the line. This is your R and this is your S. So your R is 0, 1, 0. What is your S? 1, 0, 0. Say yes or no. This is your S, 1, 0, 0. So you are moving along this line from R to S. On this line, what is the value of X? Sir, X is also changing. X is going from 0 to 1. Sir, Y is also changing. Y is going from 1 to 0. Sir, Z remains at 0 only. That means, sir, dz would be equals to 0. That I am pretty sure. But dy would be non-zero. And dx would also be non-zero. Right? So, this integral could be replaced as R to S. Sir, x will also be non-zero. Y will also be non-zero because x is going from 0 to 1. Y is going from 1 to 0. So, they are having some variable values. They are variable. Plus, Z will be 0. Z is 0. Z is always 0. Here, Z is always 0. Plus y dy. This is what we are getting. This is something we are supposed to calculate now. What does that mean? Now we will have to write down this parametric equation only, because now I am not left with, now I cannot do anything, no. right? Everything I need to take in one variable, which is t. Everything I will have to replace in one variable only. So what I will do is that I will have to write down the equation of this line. What will be the equation of this line? Now there is no method that I have to write down the equation of this line, which will be, sir, r to s I am going. So this will become my x1, y1, z1. So x minus x1 upon x2 minus x1, y minus y1 upon y2 minus y1, z minus z1 upon z2 minus z1 will be equals to t. So from here, x equals to t you are getting, y equals to 1 minus t you are getting, and z equals to 0 you are getting. X equals to t. T is also a variable only. X equals to t you are getting, x minus 0 divided by 1 would be x equals to t, y minus 1 divided by minus 1. So y equals to 1 minus t, and this is your z. So dx would be equals to dt, and dy would be equals to minus dt, right? Now from where to where t will go? So by anyone you can check. You can say that, sir, if x is going from 0 to 1, what you will say that, sir, if x goes from 0 to 1, if x equals to 0, what is the value of t? X equals to t. So if x is 0, then t is also 0, and if x is 1, then t is also 1. So if you say that, sir, x is going from 0 to 1, then t will also go from 0 to 1 only. Or you can check with respect to y as well. Y equals to 1 minus t, right? Y equals to 1 minus t. Y is nothing but 1 minus t. So you can check with respect to y as well. What you will check? Sir, what is the value of y is going from 1 to 0, no? So if y is 1, then what is the value of t? So t is 0. And if, sir, y is 0, then value of t is 1. So if y is going from 1 to 0, if y is going from 1 to 0, if your y is going from 1 to 0, then t is going from 0 to 1 only. Then t is going from 0 to 1 only. So by anyone you can check. Whether you check with x, you check with y, by anyone you can check. You don't need to check again and again. Just simply say that, see that x equals to t. That means if x is going from 0 to 1, then t will also go from 0 to 1 only. Now what you can do is that this complete thing could be replaced with a single variable, which will be t. So what is x? X is nothing but t only. So what you will do, from r to s, you are going to replace your integral now. So x will be t, what will be y? Y will be 1 minus t. So x will be t, y will be x will be t, and y will be 1 minus t. Say yes or no? X will be t, x will be t, y will be 1 minus t. And what is dx? Dx is dt. Dx is dt. Plus, what is y? Y is 1 minus t, and what is dy? That is minus dt. Y is 1 minus t, y is 1 minus t, and what is dy? What is dy? Dy is minus dt. Dy is minus dt. From r to s we are going, from r to s. That means t is going from 0 to 1. From r to s means t going from 0 to 1. So let's replace that. What you are getting? T going from 0 to 1. This will be your dt, you can take outside. So what you will get here? T plus 1 plus t minus 1. So 2t you are getting here. 2t dot dt. Say yes or no? Simply you need to solve this integration. This integration is not a difficult task. The limit of t you can directly get from here, that t is going from 0 to 1. T is going from 0 to 1. Just look at this scenario, you will be able to understand. Very simple it is, nothing else. Nothing difficult here. When you are moving, sir, dz is 0. I go to another, sir, dx dy. I need to write down the equation of the line. I wrote down the equation of the line, sir, x equals to t, y equals to 1 minus t, z equals to 0. This is known as parametric equation. This is the parametric equation. Directly this equation might be given in the examination hall. Directly this equation would be given. Okay, so this parametric equation is given from here, dx equals to dt, dy equals to minus dt. I need to find out the limit of t. So if x equals to t only, so x is going from 0 to 1. So t is also going from 0 to 1. Or you can find out with respect to y as well. Both will give the same answer. Simply I put it, I got the answer. When you integrate, integration will come out to be 1. So from r to s, a dot dl is also coming out to be 1 only. There you go. So what you see, when you are moving from, there was some line that we have written here. This particular line we wrote down. This particular line we wrote down, right? So when we solved everything, we found out that, what we find out? That this value is coming out to be 1 by 2. This value is also coming out to be 1 by 2. And this value is coming out to be 1. So sir, final answer is 2. This is the final answer. Sir, it took a lot of time in the examination. Will I spend so much of time, sir? So much of pages. First of all, in the examination, they don't ask this much, like 3 lines. I know P to Q, Q to R, R to S. In the examination, they ask only 1 line. Again, even if they ask 3 lines, no, then within 3 minutes you can do it. First of all, you will see, sir, dz only is changing here. So quickly you will be able to write down the answer 1 by 2. Then, sir, here you will see only dy is changing. Quickly you will be able to write down the answer. Here you will have to write down the equation of line. That's it. Because here x and y both are changing. Z is not changing. X and y both are changing. So very quickly you will be able to solve it. Believe me, as of now we are explaining. That's why it is taking so much of time. It is taking so much of pages as well. But in the examination, it will not happen. Say yes or no. Okay. Let's solve the next question. You will try to do on your own. Ditto similar kind of problem is there. Similar kind of problem. It's just that now from 0, 0, 1 to 0, 0, 0, I guess same field we have taken. X plus y, 2y minus z. Is it the same? No, it is not the same field. So different field it is. Okay. So 0, 0, 1 to 0, 0, 0. Then from 0, 0, 0 to 1, 2, 1. So here what do you think? What is changing? X, y, z, everyone is changing. And here what do you think what is changing? From 1, 2, 1 to 1, 0, 1. So what is changing? What do you think? Only y is changing. And here who is changing? Only z is changing. So can you solve it in a quicker manner? I'm not saying very quick manner, but try to solve it in a decent way. But this will take some time. This will take some time. These two should not take some time. P, Q, R, S. So from P to Q should not be taking much time. Why is that so? Because for PQ, what do you know? That, sir, only Z is changing. Z is going from 1 to 0. Sir, here X is fixed at 0 only. Y is also fixed at 0. Dx will be 0. Dy will also be 0, sir. Sir, dz will be non-zero. Now I know that, sir, how my A dot dl will look like. How my A dot dl will look like. A dot dl from P to S. How it will look like? Sir, x plus y dx 2y minus z. y minus z dy plus x plus z dz. Now if I am going from P to Q, I would know that, sir, this will also be 0. This will also be 0 only. So what I will be left with, only z part I will be left with. Along with that, sir, x is also 0. So what I am left with, z dz. So when I am going from P to Q, A dot dl can simply be replaced with z dz only. With z going from 1 to 0. Z going from 1 to 0. So what answer I will be getting? Minus 1 by 2. Did you understand? How did you get minus 1 by 2? Sir, here simply I wrote down this thing. Dz is non-zero here, sir. Let it be non-zero. X is 0 here. Sir, x is always 0. So I put x equals to 0. Z dz I was getting with z going from 1 to 0. Z going from 1 to 0. Answer is minus 1 by 2. This is the first we have got. P to Q. Now we need to go from Q to R. Now that is interesting. Q to R is interesting. Not interesting like you will be able to solve it from Q to R. What is the scenario from Q to R? What kind of line you are having? Sir, this is a line in 3D and all 3 coordinates are changing this time, sir. 0, 0, 0 to 1, 2, 1. Say yes or no. All 3 coordinates are changing. So what will be the equation of line? Sir, Q to R, Q to R. So this will become my x1, y1, z1, x2, y2, z2. X minus x1, x2 minus x1, y minus y1, y2 minus y1, z minus z1, z2 minus z1 equals to t. अरे भाई यहाँ पे भी 0 ही आएगा ना. z minus z1 upon z2 minus z1. So x equals to t, y equals to 2t and z equals to t. This is the scenario that you are getting. So dx dt dy 2 dt dz dt. Right? Now I know that, sir, x is going from 0 to 1. X is going from 0 to 1. X equals to t only, so t will go from 0 to 1 only. You can check from anyone. You can see that z is also equals to t. Z is also going from 0 to 1 only. So t will go from 0 to 1 only. Everywhere the answer would be same only. Everywhere the answer would come out to be 0 to 1 only. What about for y? Sir, y is going from 0 to 2. And y equals to 2t. Y equals to 2t. Y equals to 2t. So 2t will go from 0 to 2. What does that mean? So t will go from 0 to 1. That means, that simply means t will go from 0 to 1. So everywhere t will go from 0 to 1 only. That's it. Now just you need to replace, nothing else. Only thing you need to do is the replacement, nothing else. From Q to R, A dot dl. I know the limit of t will go from 0 to 1, and all the variables x plus y, that will be x plus y will be 2t plus t will become 3t, and dx will be what? dt only. So 3t dot dt. Is that understandable to you? X is t, y is 2t. So x plus y will become 3t, dx is dt only. Now 2y minus z, 2y minus z, that means 2y is 4t minus z, which is t only. So 2y minus z will become 3t dot dy. What is dy? Dy is nothing but 2 dt. Dy is nothing but 2 dt plus, next is x plus z. X plus z, x plus z means 2t. X plus z means 2t dot dz. What is dz? Dz is dt. So what you are getting? 6, 9, 11t, right? This will be 2, this will be 6, and this is 9. 6 plus 3, 9, 9 plus 2, 11. So t going from 0 to 1, 11t dot dt, 11 by 2. This is the second scenario that you are getting, 11 by 2. So when I am going from Q to R, A dot dl, I am getting 11 by 2. You can say 5.5. Now from R to S, can you quickly solve it? From R to S, from R to S, A dot dl. From R to S, A dot dl, when I am supposed to calculate, no, sir, I can directly see one thing. Sir, 1 to 1 to 101. From 1 to 1 to 101. From 1 to 1 to 101. So you can always see that, sir, x is always fixed at 1. Sir, y is changing from 2 to 0. And sir, z is always fixed at 1. So dx will be, sir, always 0 because x is constant. Sir, dy would be non-zero, and sir, dz would also be always 0. But this time, important thing to note, that z would be fixed at 1, x would be fixed at 1. Previously, they were all fixed at 0 only, but they will be fixed at 1 now. So dy would be non-zero. So what is our integral? Our integral is this. This is our integral, no? So you know that, sir, dz would be 0. This would be 0. But sir, this would be non-zero. Along with that, z would be 1 this time. This would be 1. This would not be 0. Z would be 1 this time. Okay. I hope you did not do this error. So this time, sir, 2y minus 1 dy as it is. This will be the scenario. 2y minus 1 dy. Because z is 1 here. So y is going from 2 to 0. Y is going from 2 to 0. Y goes from 2 to 0. Y goes from 2 to 0. 2 to 0. Okay. So what answer you are getting? Y square minus y from 2 to 0 minus 2. Right? Yes, minus 2. So when you add all of them, answer is coming out to be 3, I guess. So yes or no? 8. What is 11 by 2? 5.5 minus 5. 5. Square by 2 minus y. अब कहाँ कैलकुलेशन एरर हो गई भाई? ये लोग 8 आंसर बोल रहे हैं. What answer we are getting? Minus 1 by 2, 11 by 2, and here the answer that we are getting is minus 2 from 8 to 2. 2y minus z, did we write down 2y minus z, x plus y dx, x plus z dz, 2y minus z, 2y minus z. What is the value of z? Value of z is 1 only, correct? So what will be the integral? Y square by 2 minus y, 2 to 0, 0 minus 2 square will be 4 minus 2, minus 2. So what is 11 by 2? 11 by 2 is 5.5. Answer is 5 to PQR. Everything goes correct only. Where is the error? So basically now we need to add, no, everything we need to add from P to R. P to R A dot dl. So first we got minus 1 by 2, then we got plus 11 by 2, and then we got minus 2. So my answer is coming out to be 11 by 2 minus 1 by 2 will be 5 minus 2. 3 is my answer. Let me recheck the calculation. Okay. Yeah, so I checked the calculation. What was our answer? 3 was our answer. That is absolutely correct. Okay. So 3 is absolutely correct. I checked with the ChatGPT as well. So 3 is absolutely correct. This 8 is wrong. This is wrong. Okay. This is wrong. So 8 is completely correct. So this is just slowly solve the question and you will be able to get the answer. Okay. Mostly there are high chances that this kind of question in the examination they can ask. That you are moving from 0, 0, 0 to 1, 2, 1 and then calculate this A dot dl. Here we have taken 3 paths from P to Q, Q to R, R to S, and then again from S to P also I would have taken. So these 3 paths I have taken, but in the examination anything could be asked. Any of the paths could be asked. Directly minus 1 by 2 they can ask, or 11 by 2 they can ask, or this again minus 2 they can ask. Eventually the answer is coming out to be 3. Let's go to the next question. Try solving it on your own. You will be able to solve it. If you just have some patience, no, you will be surely able to solve it. Same kind of question is there. You are moving from 0, 0, 1 to 0, 0, 0, then from 0, 0, 1 to 1, 1, 1. Previously, they were the straight lines. They were completely straight lines. Straight line. Straight line. So we had to write down the equation of these straight lines. This time they have already given the equation. This time it is not a straight line, but they have given the equation. So the scenario looks somewhat like this. That this is your XYZ coordinate system. How you are moving is that this is your x cross y comma x cross y and z. So sir, you are moving somewhat like this, that you are moving from 0, 0, 1 to 0, 0, 0. And then from here you need to reach to the point 1, 1, 1. Now this is surely not a straight line. The equation of the line that is given is y equals to x square, z equals to x. Sir, I don't know how the line looks like. What will be the curvature of the line, but I just know that, sir, I will be reaching to this point. Following the equation which is given as y equals to x square, z equals to x. Y equals to x square, z equals to x. And then from 1, 1, 1 to 1, 0, 1. From here to 1, 0, 1. You reach to this point. This is the path that you are following. From P to Q, then Q to R, then R to S. Sir, P to Q is very straightforward. R to S is also very straightforward. Sir, directly I know the results. Directly means, sir, very easily I will be able to write down. Sir, from P to Q, if I am going, I already know one thing. That, sir, X is always constant at 0. Y is always constant at 0. Only Z is moving, sir, from 1 to 0. Z is moving from 1 to 0. Dx is 0, sir. Dy is also 0. But dz would be non-zero. Now if I calculate my A dot dl, only the dz term I need to write down. So directly from here, P to Q, only the dz term would come. Only this term would come. Xy dot, you know that, sir, how A dot dl would look like. Sir, A dot dl will look somewhat like this. Yz dx plus xz dy xy dz. So they will come out to be 0 only this term would be left. Xy dot dz. Xy dz. Right? Sir, dz is non-zero. But sir, xy is 0. No, this is also 0. This is also 0. So this answer will come out to be 0 only. This has simply become 0 dot dz, z going from 1 to 0. So 0 dot dz would be 0 only. This is from P to Q. Let's directly write down from R to S as well. From R to S, what you will be getting? From R to S, A dot dl. So from R to S, what is the scenario? So from R to S, sir, X is fixed at 1. Z is also fixed at 1. But sir, Y is changing from 1 to 0. Y is changing from 1 to 0. Dx is 0. Dz is 0. Dy is non-zero. So what you are getting? From R to S we are going. Dy is non-zero. Dy is non-zero. So xz dy. Xz dy. X into z dy. X into z dy. Value of x is 1, value of z is 1. Value of x is 1, value of z is 1. Dy remains as it is. Y going from 1 to 0. Y going from 1 to 0. The answer is minus 1 here. So from P to Q it is 0. From R to S it is minus 1. No issue about it. No issue about it at all. Now what is left? From Q to R. From Q to R. When you are moving from Q to R, everything is changing. Sir, X is also changing, Y is also changing, and Z is also changing. Everything is changing. From Q to R. From Q to R. Right? Everything changes. Dx also changes. Y also changes. And Z also changes. We need to write down everything in one equation. What is the equation of this line? Y equals to x square, Z equals to x. Y equals to x square and Z equals to x. We need to write down everything in one variable. If I assume x as t, then what will be your y? So if x is t, y will become t square, and what will be your z? Z will become t only. That's it. What will be your dx? Dx will be dt. What will be dy? Dy will be 2t dt. And what will be dz? Dz will be equals to dt. There you go. And what about the limit? Sir, x is going from, on this line, x is going from 0 to 1. Anyone you can take. X goes from 0 to 1. X goes from 0 to 1. X goes from 0 to 1. Then from where to where t will go? T will also go from 0 to 1 only. There you go. Very, very simple thing. So replace everything now. Job done. Your A dot dl going from Q to R. This was the scenario, no? YZ, dx, everything. This was the scenario. Q to R. So y into z, that will become t cube dx dt plus x into z. X into z will become t square dot dy, that will become 2t dt. So it will become 2t dt plus x into y, that will be t cube dt, with t going from 0 to 1. So t cube, 2t cube and t cube, it will become 4t cube. T going from 0 to 1, 4t cube dot dt. Say yes or no. Right? So if you solve it, what answer you get here? T cube by 4, this answer will come out to be 1. So what all answer we have got? 1, minus 1 and 0. So just simply we need to add all of them, that when I move from P to R, A dot dl. So first I was getting 0, then this 1 I was getting, and then minus 1. Final answer is 0 only. That's it. This is the final answer. Is that understandable to you or not? So Q to R was not a difficult task. Sir, P to Q, R to S, very easily I can do. P to Q, R to S, very easy I can do. I need to move from Q to R. So previously, sir, I need to write down the equation on my own. Here equation is already given. Y equals to x square, Z equals to x. I need to bring them in one variable. X equals to t, y equals to t square, z equals to t. From there, everything I wrote down. Limit of t also I can write down. Job done. Understandable? Very straightforward question. Next question, try doing it on your own. This time you need to work on the closed line. That means you will start from A, you will go to B, you will go to C, you will go to D, and then again to A. This time you need to calculate a closed line integral A dot dl. What does that mean? That means, sir, A to B, A dot dl, B to C, A dot dl, C to D, A dot dl, and D to A dot dl. Again, A, B, C, D, Y, I am writing down PQRS, I need to write down PQRS, okay, because A is the vector field itself, no? So let's write down PQRS. PQRS. So P to Q, Q to R, R to S, S to P. 8 dot dl. Can you do it on your own or not? Absolutely, clearly you can do. A dot dl, can you write down? Absolutely, sir. This I will copy as well, because again and again I will have to write down. So xy minus z dx plus x square plus y dy plus 2x minus z dz. So P to Q I need to move. So 1, 1, 0 to 2, 1, 0. अरे भाई ये क्या हो गया? Yeah, right, yet. So what is changing? X is changing. Only X is changing. Y and Z are constant. Y is constant at 1, Z is constant at 0. In the whole scenario, everywhere Z is 0. No, always Z is 0. Always Z is 0. Always Z is 0. Always Z equals to 0. In the whole scenario, because everything is happening on xy plane. So here, everywhere you can put Z equals to 0. If always Z equals to 0, that means always Z, dz would also be equals to 0 only. In the whole scenario, Z is always 0. That means dz would also be always 0. So this could be replaced. A dot dl can be simplified in this manner. A dot dl can be simplified. Sir, xy dx, because z is 0. Z is always 0. So xy ds, and dz would also be 0. So this will be gone. Plus x square plus y dy. This is how it can be replaced. Calculate the integral, closed line integral, calculate the closed line integral. So path by path we need to go. Let's go from P to Q. Let's go from P to Q. So in P to Q, what is the scenario? Sir, x is changing, y is fixed at 1. Y is fixed at 1. Sir, x is changing. X is going from z, we will not even talk, no, because z is always 0. So z we will not talk about. X is changing from 1 to 2. X is changing from 1 to 2. So sir, dy would be equals to 0. Dx would be equals to non-zero. That's it. So let's solve this integral. From P to Q, it would look somewhat like this. Dy would be 0, dx would be non-zero. Dx would be non-zero. Y is fixed at 1. Y is fixed at 1. So x dx. Y is fixed at 1. X dx. Say yes or no? Y is fixed at 1, no? Basically, it will become xy dx. Xy dx, because dy is gone. Xy dx. Now you know that, sir, y is fixed at 1. Y is fixed at 1. So it will become x dx. With x going from 1 to 2. X going from 1 to 2. X going from 1 to 2. So what will be x square by 2? 1 to 2. 4 minus 1 divided by 2. Answer is 3 by 2. Understandable? Very simple. Right? Next, Q to R we need to go. P to Q, Q to R. Q to R we need to go. So here what you can see, x is fixed at 2. X is fixed at 2. But y is changing from 1 to 2. Y is changing from 1 to 2. So dx is 0, but dy would be non-zero. You are going from Q to R. Who is non-zero? Dy is non-zero. So x square plus y dy. X square plus y dy. X square plus y dy. With y going from 1 to 2. Y going from 1 to 2. X square, what will be the value of x? X is fixed at 2. This x is fixed at 2. So this will become 4 plus y dy. Limit of y we have put. So what we will be getting? 4y plus y square by 2. Always solve integration with patience only in the examination. Don't do in a hurry. Because here you might be messing up x equals to 2. All these things don't do in hurry. Always with patience. Just patience is the key. From 1 to 2. So 8, let's solve it in a rough way. So 8 plus 2 minus 4 plus 1 by 2. 6 minus 1 by 2. Right? I always double check my calculation. Always I double check my calculation. देखो कितनी बार चेक कर रहा हूँ, मेरे को खुद पे विश्वास नहीं होता कई बार कि भाई who knows, you might have done something wrong. Q to R, R to S. R to S. R to S. So here what do you think what is fixed? X is changing, Y is fixed at 2. Y is fixed at 2. But X is changing from 2 to 1. That means dy is 0. But dx is non-zero. So how the integral will look like from R to S? Xy dx only it will look like, no? Because this is non-zero and this is 0. So xy dx it would look like from R to S, where I need to put the limit of x, y is 2. So 2x dx. Limit of x is going from 2 to 1. X is going from 2 to 1. X is going from 2 to 1. So x square from 2 to 1. minus 3 minus 3 P Q R S, then again S to P, from S to P. Y is fixed at, sorry, X is fixed at 1, X is fixed at 1, Y is changing from 2 to 1, Y is changing from 2 to 1. So what is dx? Dx is 0, dy is non-zero. From S to P, what is dy? Dy is x square plus y dy, x square plus y dy. Y is going from 2 to 1. X square, x is fixed at 1, y as it is, dot dy. So y plus y square by 2, from 2 to 1. So what you will be getting? 1 plus 1 by 2 will be 3 by 2, minus 2 plus 2, 4. 3 by 2 minus 4. What you will be getting? Minus 2.5, right? This is 5.5. Better here I should write down 5.5. This is 5.5. This is 1.5. This is minus 2.5. So all these things we have calculated. All the paths we have calculated. Very simple concept. X is constant at 1. Yes, X is constant at 1 only here. So very simple process. We have calculated everything. Now simply we need to add them up. What answer we will be getting? 1.5. 3 by 2 will be the answer that we will be getting. 3 by 2 is the answer that we are getting. We simply add all of them and the answer that we get is like basically 1.5, 1.5 from P to Q, then from Q to R 5.5, then from R to S minus 3, then from S to P minus 2.5. So whole calculation if we do from P to again P, so better I should write down closed line integral over the curve C. This curve is known as curve C, okay? Everywhere it was written, no, there, here as well it was written curve C. So what is the meaning of curve C? This curve C we are talking about. This is the curve C. This is your curve C. This is the whole curve C, okay? So over the closed curve C, A dot dl is coming out to be what? 0. A dot dl is coming out to be 0. It's not 0, 3 by 2, sorry. It is coming out to be 3 by 2. 1.5, 5.5, then these two will be added 1.5. So it is coming out to be 1.5. That's the answer. Okay. Now there is a method 2 as well for this. Method 2. Method 2. What I am writing down? Only for, in capital letters I will write down, only for closed line integral. Only for closed line integral. Closed line integral. Only for closed line integral. This method is valid only for closed line integral. If this second method was valid for the previous cases as well, for these cases as well, we have solved this question. No, this question we have solved. This question we have solved. If it was valid for these questions, then I would have told this method here as well. Are you able to answer this point? But here I did not tell any other method. No, only one method was there. But for this is a closed line integral now. For closed line integral, there is a special method. Okay. So what I will do? First of all, I will calculate del cross A. I will calculate the curl of A. What I will calculate? Curl of A. Del cross A I need to calculate. What will be the answer of del cross A? So I cap, j cap, k cap, I cap, j cap, k cap, del by del x, del by del y, del y del z. xy minus z, x square plus y. xy minus z, x square plus y. xy minus z, x square plus y, 2x minus z. 2x minus z. I cap, differentiate, 0. Minus j cap. All these calculations you should be able to do on your own. With respect to I cap, what you will see, partial differentiation with respect to y, partial differentiation with respect to z, both will be 0. Minus j cap, partial differentiation with respect to x, 2. Minus partial differentiation with respect to z. Partial differentiation here with respect to x will be 2. Partial differentiation with respect to z here will be minus 1. Minus 1. So this will become plus 1. plus k cap. Partial differentiation with respect to x will be 2x. Partial differentiation with respect to x will be 2x. Partial differentiation with respect to y will be x. So eventually what answer we are getting? Minus 3j cap plus x k cap. Say yes or no. This is what we are getting. Understandable? Yes. This is what we are getting. So this is your del cross A. Del cross A came out to be minus 3j cap plus x k cap. So for closed line integral A dot dl is equal to del cross A dot ds, where ds is the, for what is ds? ds is the surface area. ds is the surface area vector. So now which area you are talking about? The area which is enclosed by this closed surface, or I should say the area which is enclosed by this closed line. This closed line is enclosing some area. No, this is the scenario. This scenario was given. Let me again copy it. First of all, I solved this question with A dot dl. I went from P to Q, Q to R, R to S, and then again from S to P. Question was solved. But now, sir, you are saying there is another method that first you calculate del cross A, then del cross A dot ds you calculate, your job would be done. Now, sir, what is your ds now? Now, what is the surface you are talking about? Which surface area you are talking about? So, whatever the closed line, let's just say the closed line was like this. This was your closed line. You started from here, you went somewhat like this. This was your closed line. So, what is the surface area it is enclosing? This is the surface area it is enclosing. No? So, this is the ds I am talking about. This is the ds I am talking about. So, what will be your ds? This will be your ds. Okay, here you need to talk about this surface area. This will be your surface area. This will be your surface area. So you need to write down the ds vector for this. Can you write down the ds vector for this? Sir, when I am moving on this particular surface, directly I can see that, sir, I am only moving in xy plane. I am only moving in xy plane. So directly I can write down dx dy. It is not a curved surface. I am moving only in xy plane only. That's it. So dx dy. What about the direction? Sir, the direction could be either plus az cap or minus az cap. This is your z axis. So direction could be either plus az cap, since it is a open surface. No, sir, it is a open surface. This is like a open surface. So direction could be either plus az cap. This is the surface. So either it could be plus az cap or it could be minus az cap. So sir, two possible answers are there. Either plus az cap or sir minus az cap. Or sir minus az cap. Which I will have to accept. Which one I will accept? So I will see the rotation. I will see how I was moving when I was talking about line integral. So I was moving in this manner. No, I was moving clockwise. This is my movement from P to Q, Q to R, R to S. So sorry, movement is anti-clockwise, not clockwise. Movement is anti-clockwise. The movement is anti-clockwise. Use the right hand rule. What do you need to use? Use the right hand rule. Right hand rule. Use the right hand rule. So when you use the right hand rule, where it is pointing? It is pointing towards U. That means it is pointing towards az gap. So which one will you accept? This one you will accept, and this one you will not accept. Is that understandable to you? So dz you will be able to understand. You need to write down the surface area. Sir, two possible answers are there. Two possible answers are there. Which answer I need to take? I need to take this direction or this direction. I will see what I will see. I will see the rotation. Rotation I am doing in the anti-clockwise direction. Since we are doing the rotation in the anti-clockwise direction, it is pointing towards, using the right hand rule, it is pointing towards plus az gap. So plus az gap you will accept. Okay. So what I need to write down that, sir, my A dot dl that I have written, sir, that is for this curve C, sir, that is coming out to be for the surface area del cross A dot ds. What is your ds? Sir, ds is nothing but dx dy az cap. Okay, so what is your del cross A? So del cross A is coming out to be minus 3j cap plus x k cap. Minus 3j cap plus x k cap. Here also I will write down k cap only. This is k cap plus az or k cap. Here dot product is there. So dot product with k cap, because dx dy is a constant number. No, it is not a vector quantity. So dx dy you take outside. K cap. So do the dot product. J cap dot k cap will be 0. K cap dot k cap will be 1. So what you are getting? That over this surface region, you are supposed to calculate x dx dy. So in place of writing s here, I can write down Here I can write down S, but here I will write down region R. So over this region R, you need to calculate this double integral. Do you know how to calculate this double integral? Over this region R, you need to calculate this double integral. Do you know how to calculate this double integral? Absolutely, sir. I need to write down, I need to take a strip. I need to take a strip. So I will take a strip. This kind of strip I will take. I can directly see here that sir, my x is going from 1 to 2 and y is also going from 1 to 2. X is also going from 1 to 2 and y is also going from 1 to 2. So this kind of things, this kind of double integral we have already studied. X dot dx dot dy. X is going from 1 to 2, y is going from y is also going from 1 to 2. Both are the constant limits, so any limit you can write down. So here what you will get, x square by 2, that will become 3 by 2, and for y it will be 1 only. So when you solve it, answer is coming out to be 3 by 2. That's it. This is the answer. So what did you understand? Answer is very simple here. So here this method would be less hectic. No, here you need to work for all the from P to Q, Q to R, R to S, then S to P. Then you add all of them and then you get the answer 1.5. But here what you need to do, just as I see, sir, close the integral. Sir, it will be enclosing some surface. It will be enclosing some surface. Sir, since it is enclosing some surface, A dot dl could be replaced as del cross A dot ds. Can I calculate del cross A? Absolutely. ds, sir, I can directly see what will be ds, sir. Dx dy az cap or minus az cap is also possible. I need to see the rotation. It is coming towards me. Plus az cap I will write down. So dx dy k cap. Simply solve it. This is the double integral I am getting over the region R. Over this region R, I need to calculate x dot dx dy. X dot dx dy. Do you know how to calculate this? Absolutely, sir. I clearly know how to calculate this. X is going from 1 to 2, y is going from also 1 to 2. Get the answer 3 by 2. And this particular thing that I applied here, what this is known as? This is known as Stokes theorem. What it is known as? This is known as Stokes theorem. Stokes theorem. Stokes theorem. But that's not it. There is a catch here, that you can apply it for closed line integral. Along with that, in whichever the region that you are applying, no, let's just say I am applying in this particular region, right? I am applying in this region. I am applying the Stokes theorem in this particular region. So in this region, at all the points, your vector field A should be continuous. Your vector field A should be continuous. What I mean to say is that next statement is written. Okay, let's hide this. Let's not read this one. As of now, let's not read this one. What is the meaning of curl here? Let's read the statement. The closed line integral of a vector field F around the closed curve C is equal to the surface integral of the surface integral of the curl of the vector field over the surface S bounded by the closed curve, provided the vector field F is continuous in the surface S. This is the important line. This theory we already know. F dot dl will be equals to double integral del cross F dot ds. This we already know. Field F should be continuous over surface S. What is the meaning of this? Let's just say this is my closed line. This is my closed line. This is my closed line. This is my curve. This is my closed curve C. I am supposed to calculate over the closed curve C. I am supposed to calculate F dot dl. This is what I am supposed to calculate. Now my vector field F is minus y upon x square plus y square I cap plus x upon x square plus y square j cap. This is my vector field F. What is my enclosed region? This is my enclosed surface area. This is my enclosed surface area. I can see that, sir, this is in the P by Q form, no? P by Q form. In this surface area, there will be a point called 0, 0. What will be the value of vector field F at 0, 0? So it would come out to be 0 by 0 I cap plus 0 by 0 j cap, which is undefined. It is not continuous. Undefined. What does that mean? Stokes theorem cannot be applied. Stokes theorem cannot be applied. Stokes theorem cannot be applied. Is that understandable to you? So always you need to check one thing, that's directly del cross F dot ds you will not do. I will always check one thing. What will you check? I will check, sir, whether my function is continuous or not. Only the problem will be only there when it is in the form of P by Q. Look, is it in the form of P by Q here? It is not in the form of P by Q, no. P by Q, I am saying P by Q. If it is in the form of a rational, then only there is a problem. But here, xy minus z, x square plus y, 2x minus z, at all the point it will be continuous, no issue. Only just make sure one thing, that if denominator is becoming 0, then there is a problem. Denominator can become 0 at x equals to 0, y equals to 0. So in the examination, there will be only one question. And if I am applying the Stokes theorem, I will surely check this particular thing, that sir, if my function is continuous or not. The main problem will be at 0, 0 only. So by the question, you will be able to understand. Is that clear or not? Say yes or no. Okay, this was your x-axis, this was your y-axis. Okay, and from here, can you write down the definition of curl? So I told you when we were studying about the curl, I told you that I will tell you the meaning of curl later on. I only talked about the direction. There we talked about the direction, that if I put a ball, if it rotates in clockwise direction, then thumb is going inside. So direction would be cross. If it is coming towards us, that will be dot. So all these things we taught. We only talked about the direction. But what does it represent? What does curl represent? So from here, if you write down del cross f, how it can come? So this ds can go downward. So f dot dl divided by ds, when it goes downward, no, so del s will tend to 0. This ds will tend to very small number. It is a very small number. ds is a very small number. So what is written? Curl of a vector field represents the circulation per unit surface area. This statement could be given in the examination, and they can ask which of the following statements are true. So first one, the divergence. What does gradient represent? Gradient represents the maximum rate of change. Gradient would represent the maximum rate of change. The direction of gradient would be in the direction of the maximum rate of change. What does curl represent? Curl represents the circulation per unit surface area. Circulation per unit surface area as the surface area approaches 0. Or what could be written? Circulation per unit infinitesimal surface area. What is the word? Infinitesimal. Approaches 0 means infinitesimal. The word is infinitesimal. 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 This word could be written. The meaning of infinitesimal is very small surface area. So the physical significance of curl is it will represent the circulation over per unit surface area. Only for the statement purpose, who knows in the examination, statement wise question is coming, which of the following statements are true? So gradient represents the direction of gradient will always be in the direction of maximum rate of change. Correct statement. What curl would represent? Curl would represent the maximum, curl would represent the circulation per unit surface area. Then you would be thinking, sir, what it is? Circulation per unit surface area. I never studied it. From the Stokes theorem, it is coming. Okay. So this is the physical significance of curl, and this is the Stokes theorem that we have studied with respect to the question we have seen first. That sir, I was supposed to calculate 8 dot dl. Very easily I was able to calculate. But sir, then I thought that I have another method for the closed line integral only for the closed line integral, because it will be enclosing some surface area. Since it is enclosing some surface area, so sir, del cross A dot ds. Del cross A I am able to calculate. ds also I am able to calculate. Job is done. Okay. Let's go to the next question. Try doing it on your own. Very good question it is. A dot ds you need to calculate. A dot ds you need to calculate. It is an open surface. What it is? It is an open surface. S is the portion of the plane. Can you draw this plane? Can you write down the ds vector for this plane? If bold letter is written, no, that means they already it is vector only. A vector dot ds vector. Okay, this is A vector only. So first target is, can you write down the ds vector? Have I taught you this or not? Completely, sir, you have taught us how to write down the ds vector. So first you make the plane. The plane is lying in the first octant. Can you draw the plane? Yes, sir, you can draw the plane. In integral calculus, we have studied how to draw this plane. It will be cutting x-axis on 4, 0, 0, y-axis on 0, 4, 0, and z-axis on 0, 0, 4 in the first octant. Then you need to write down the ds vector. Is it very straightforward? No, sir, it is. If we are moving on the ds vector, if we are moving on the surface area, how the surface would look like? The surface would look, sir, somewhat like this. Only in the first octant I am supposed to make x, y, or let's write down x cross y, z. X cross y, z. So, sir, the surface I already know, I have already studied that, sir, surface would look somewhat like this. This is how the surface would look like. This point will be 4, 0, 0. This point will be 0, 4, 0. This point would be 0, 0, 4. And sir, this will be the surface. This will be the surface. This is the surface that is there. The slanted surface, this kind of surface. These are your coordinates. This is the surface. This is the surface that we are having. This is the surface that we are having. So what is the equation of the surface? The equation of the surface is x plus y plus z equals to 4. You need to write down the ds vector. Equation is x plus y plus z equals to 4. What I can do? I can do one thing. Z equals to 4 minus x minus y. X can be a free variable, y can be a free variable, but z will be fixed. Z will be fixed. These two will be free. So how my ds could be written? So ds could be written in the dx dy format. But is that correct? Absolutely not. Only dx dy is not correct. Along with that, sir, another factor would come into action. That would be 1 plus zx square plus zy square. So yes or no? So what is zx, sir? That is 1. Partial differentiation of z with respect to x. Partial differentiation of z with respect to x, that will be minus 1. Partial differentiation of z with respect to y, that will also be minus 1. So we are getting under root 3 dx dy. This is the ds we are getting. What about the direction, sir? So direction, now sir, I am having z x plus y plus z equals to, what I am having, x plus y plus z equals to 4. I need to find out the surface area direction. Do I have any tool? Absolutely, sir. You have any tool. You make a function phi which will be x plus y plus z minus 4. Then what you do? You calculate the gradient of phi. So gradient of phi would be I cap plus j cap plus k cap. This is the gradient, but you only need the direction. So divided by under root 3. Basically, first I am calculating the gradient. Gradient of phi. Gradient of phi, what it will represent? It will represent the surface area vector. That is coming out to be I cap plus j cap plus k cap. But what do I need? I only need the direction. No, I only need the direction. That means I need the unit vector. I need the unit vector which will be representing the direction of surface area. That would be I cap plus j cap plus k cap by under root 3. Now let me know what I have written, that is correct or not. I cap plus j cap plus k cap by under root 3. Yes, sir, this will be one of the direction. I cap plus j cap plus k cap divided by under root 3. Now let me know, is it a closed surface? That, sir, I have taken surface area vector to be outside. The surface area vector that I have taken, sir, is this. This is my surface area vector. Is it a closed surface? This is the only surface. That's it. It is not a closed surface. No, this is the surface only. That's it. This is the surface. So it is an open surface only. So this is one of the surface area. Then another surface area is also possible. So another surface area vector is also possible. That would be inside it. Are you able to understand this point? So if this is one of the possible answer, then this will also be one of the possible answer. I told you this thing, that vector phi, if someone is taking in this manner x plus y plus z minus 4, another guy can take it 4 minus x minus y minus z. So two answers are possible. So which answer will you accept now? Two answers are possible. Which answer will you accept? So you will go back to the question. What is written? The surface oriented in the positive z direction. Positive z direction means, sir, whatever the ds vector that you are taking, no, it will have some factor, I don't know. It will have some factor of k cap as well. But sir, this should be positive z. That means, sir, plus k cap should come. In the ds vector, sir, plus k cap should come. Plus k cap should be there. In the ds vector, in the ds cap, you would need plus k cap. This is the requirement. So in this answer, we are getting minus k cap. In this answer, we are getting plus k cap. So this is something that I will accept. In the examination, this would be written surface oriented in the positive z direction. What is the meaning of positive z direction? That means, sir, whatever the surface area vector that you are getting, that surface area vector should have plus k cap. So I will accept that plus k cap thing, not minus k cap thing. This will be rejected. This will be accepted. Is that understandable to you? So from here, now can I write down my surface area vector? So that is coming out to be under root 3 I cap plus j cap plus k cap divided by under root 3. Here it was coming out to be under root 3 I cap plus j cap divided by under root 3 dx dy. This is a big win for you. 99 out of 100 students will not be able to write down this ds vector. I am telling you, they will not be able to write down this ds vector. It is not very straightforward. Okay, it is a big win that if you are able to write down this ds vector. Under root 3 and under root 3 will get cancelled out. So ds vector is coming out to be I cap plus j cap plus k cap dx dy. Someone would say that, sir, I could write down in dy dz as well. Yes, sir, you could have written in dy dz. Sir, I could have written in dx dz as well. Yes, but I prefer to write down in dx dy. So now what is my integral? My integral is a dot ds over the surface S. What is my A? A is 2x plus y I cap plus y minus z j cap 2x plus y I cap plus y minus z j cap plus x plus z k cap. Y minus z j cap plus x plus z k cap. Again 2x plus y y minus z, 2x plus y y minus z, x plus z k cap, x plus z k cap. Okay, dot ds vector. What is your ds vector? So ds vector is I cap plus j cap plus k cap dx dy. I cap plus j cap plus k cap dx dy. So these are the dot product. Between this vector and this vector I need to do the dot product. So what I will get? I cap will be multiplied with I cap, so 2x plus y multiply with 1, 2x plus y. Y minus z multiply with 1, y minus z. X plus z multiply with 1, x plus z. Dx dy. So what you are getting? Surface area S, here you write down. S, what you are getting? This z and z is getting cancelled out. 2x plus x is 3x plus y plus y will be 2y. Dx dy. Do you know how to calculate this particular thing? 3x plus 2y dx dy over the region R. Do you know how to calculate this? So dx dy, that means I need to come in the xy plane. Dx dy. Surface integral I need to calculate. That means I need to come in the xy plane. That means I need to take its projection in xy plane, how it will look like. So in xy plane, this is how it will look like. And first octant it is going on. That means x is also positive, y is also positive. So how it will look like in xy plane? So in xy plane, what you are doing? You are taking the projection. You are taking the projection like this. So how it will look like in xy plane? These kind of things we have already calculated. Now this question is directly from your integral calculus. What will be this coordinate? 4, 0. This coordinate would be 4, 0. And what would be this coordinate? This coordinate would be 0, 4. What will be the equation of this line? X plus y equals to 4. Right? And over this region R, you can call it surface S or region R. So over this region R, you are supposed to calculate. Over this region R, you are supposed to calculate it. Right? So what you will do? You will take a strip. You will take a vertical strip. And in this vertical strip, what you will do? You are going from, x is going from 0 to 4, but y is going from 0 to y minus x. X is going from 0 to 4. Constant limit we will take later on. Variable limit we will take first. And y is going from 0 to 4 minus x. 4 minus x. 3x plus 2y. First you need to integrate with respect to y and then with respect to x. So do this integration and get your answer correct. So x going from 0 to 4. So first I will integrate with respect to y. So what I will get? 3x y plus y square. Y going from 0 to 4 minus x dot dx. Now you calculate this integral, put the limit and get the answer. Okay. I will take a break and then I will come back. Simple, just putting the limit and getting the answer, nothing else. I will take a break and then I will come back. Yeah, welcome back. So did you solve it? So what we need to do? X going from 0 to 4. Limit we are supposed to put. So limit of y will be 4 minus x. So 3x into 4 minus x. 3x into 4 minus x plus 4 minus x whole square dot dx. Whole square dot dx. So if we solve it, x going from 0 to 4. 12x minus 3x square plus x square plus 16 minus 8x dot dx. X going from 0 to 4 minus 2x square plus 4x plus 16 dot dx minus 2x cube by 3 2x square plus 16x with x going from 0 to 4. 64 32 64 by 3. 64 by 3 plus 32. 64 by 3 plus 32. So here you can see that this will become 96 plus 64. 160 by 3. So what is the answer we are getting? 160 by 3, which is correct only. I remember the answer, it is correct only. So answer is 160 by 3. Understandable? So let me tell you one thing. In the gate examination till this date, this kind of surface have not come. Like in the gate examination till this date, they have always asked this kind of surface. Always this kind of surface has been mentioned in gate examination, where it is very simple. ds will be dx dy az gap. But slanted surface, curved surface, these kind of questions can also come. Surely it can come in future in your gate examination. So always be ready for that. Slanted surface, how will you write down the ds? So ds, only the magnitude I will write down. So I need to see free variable and fixed variable. Based on that, sir, I will be able to write down. Then, sir, direction I will be able to write down by the gradient. ds vector, if I am able to write down, after that, sir, it is integral calculus. That I already know. This I already know how to solve. Job done. Integral calculus, it is 160 by 3 is the answer. Next question, this time it is closed surface. First of all, closed surface. Second, they are asking flux. What is the meaning of flux? Flux means simply one thing. What is the meaning of flux? If they are giving you a vector field and they are asking you flux, then flux simply means A dot ds. That's it. Now through the closed surface they are asking, that means I will close it. Closed surface. But flux means this. This is the meaning of flux. Since it is written closed surface, then I will use the closed surface here. So what we are supposed to find out? We are supposed to find out A dot ds through the closed surface of the cylinder in the first octant. X square plus y square equals to 4 with z going from 0 to 5. Have we made this kind of structure already? Closed surface, but this time they are talking about a closed surface. X square plus 5 with z going from x square plus 5 with z going from 0. This is your z equals to 0. Then z equals to 1 will also be there. Z equals to 2 will also be there. And eventually you will reach at z equals to 5 as well. Okay. So closed surface they are talking about, right? They are talking about closed surface. So closed surface means that, sir, this is my xyz coordinate, but here there will be a cylinder. Look, let's just say this is your xyz coordinate, xy coordinate it is, z coordinate is coming this side. So cylinder will be here. So 5 surfaces would be there. Do you remember that particular example? We have already taken it in the basics. 5 surfaces would be there. First of all, making this diagram will be, you are able to understand that it is a cylinder. It is a cylinder which looks somewhat like this. It is a cylinder which looks somewhat like this. This is how the cylinder would look like. And there are total 5 surfaces. Since they are talking about, they have written, no, it is a closed surface. If only this was mentioned, x square plus y square equals to 4, z going from 0 to 5, then I would have taken only this surface. Then I would have taken only this surface. I would have only taken this surface. But it is a closed surface they are telling. That means this particular surface is there, side surface S1, S2, if you remember it. All 5 surface we have already made, right? I hope you remember it. In the basics only we have made it. This is our first surface. This is our S1. Arey bhai yaar. This is our S1. Right? This is our S2. This was your S1. The side, this rectangular one, S1. In, let's just say this is your X. X, Y, Z we need to make, no? So this is your X, this is your Y, and this is your Z. So in this is there in the XZ plane. This is in the XZ plane, and this will be there in the YZ plane. This surface is there in the YZ plane. So can you write down the surface area for S2? Yes, sir, it will be nothing but dy dz, and the direction would be in the minus I cap. Why is that so? Because, sir, direction would be outside, no? Because I told you, if there is a surface which is a part of closed volume, then the direction should be going out of the enclosed volume. That means it should be going out of the enclosed volume. You are moving in YZ direction, and direction should be going out of the volume. So minus I cap. What about this one? Sir, here for S1, I will write down dx dz minus j cap. Dx dz minus j cap. Dx dz minus j cap towards this, right? This is the scenario. Now there are 2 more surfaces upper side. two more surfaces, upper side and downward side as well. So there is this surface, upper side and downward side. अब भाई इसको बनाऊं कैसे मैं? How did I make this one? One surface will be downward, and other surface will be all upward, right? Now I am able to make it. This will be one surface, this is the another surface. This is one surface, x, y, z, and this is another surface, right? So what will be the surface area here? You can see that, sir, direction will be plus az gap, and we are moving in the xy plane only. It is parallel to xy plane, no? So if I call this as S3, so for S3, dx dy k cap, and what about for S4, dx dy minus k cap, right? This is S4. And what about for S5? S5 is the curved surface. For S5, writing down your surface area vector is a task, right? But that task we already know how to do it. Say yes or no. We already know for the curved surface which is given how to write down the surface area vector. Only for this curved surface. This curved surface, what is this curved surface? Sir, we already know this curved surface is S5. I need to write down the surface area vector for this. How will I write it down? Right, so for this, what is the equation? Sir, x square plus y square equals to 4, and z is going from 0 to 5. This guy is free, z is free, z is free, right? One of them you need to consider as free, other one would be dependent, right? Or you can say free, or you can say it will be fixed. So from here, what you are getting, x equals to under root 4 minus y square. And why I am able to take positive only? Because it is in the first octant. Everything is happening in the first octant. It is completely written here, first octant. So everything is already positive. Understandable? Okay then. So what will be your ds? So ds would be written as, sir, y is free and z is free. dy dz under root 1 plus x y square plus x z square. Okay, so partial differentiation of x with respect to y. So answer will come out to be minus y upon 4 minus y square, because it will come out to be 1 by 2 under root 4 minus y square minus 2y. So this is the answer that you will be getting. So here the answer would be, and what will be the value of xz with respect to z? It would be 0 only. So 1 plus y square upon 4 minus y square plus 0 dy dx, that is equals to ds. So 2 upon under root 4 minus y square dy d, why I am writing dx here, dy dz. Dz is the free variable, no? Dz is the free variable. Dz is the free variable. Dy dz. This is the value of ds you are getting. 2 upon under root 4 minus y square dy dz. Say yes or no? Okay. And what is under root 4 minus y square? That is nothing but x only. So 2 upon x dy dz. This is what you are getting. This we have already seen. What about your ds cap? What will be your ds cap? So for this surface, what is the equation we have? X square plus y square equals to 4, and z is going from 0 to 5. I need to find out a scalar function phi which will be x square plus y square minus 4 equals to 0. Okay, so now I need to find out a gradient of phi. So first I am finding out the gradient of phi, that is coming out to be 2x I cap plus 2i j cap, and if I need to find out the direction, then what will be the direction? 2x I cap plus 2i j cap upon 2 under root x square plus y square, which is coming out to be x I cap plus y j cap. Under root x square plus y square is nothing but 2. Is that clear to you? So this is the direction of phi you are getting, or this is the surface area vector that you are getting. But sir, there are two possible answers, x I cap plus y j cap divided by under root 2, and sir, other possible answer is also there, minus x I cap minus y j cap divided by 2. I hope you are able to understand. Sir, first you have calculated the gradient, partial differentiation with respect to x I cap, partial differentiation with respect to y j cap, then simply take the magnitude. Magnitude I have taken, this is what I am getting. But two possible answers are there which you will be accepting. Sir, I need to take the direction outward like this. I cannot take it inside. So outward like this is your x coordinate, this is your y coordinate. That means you are moving in plus x and plus y. Say yes or no. That means this you will be accepting, this you will not be accepting. So what is your ds vector that you are getting? ds vector for S5. For S5, what is the ds vector that you are getting? Sir, for S5, the ds vector that you are getting is 2 by x dy dz. So 2 by x. And what is the direction? Direction is x I cap plus y j cap divided by 2 dy dz. dy dz. So what you are getting? ds vector is x I cap plus y j cap divided by x dy dz. This is the ds vector that you are getting for S5. For S5. Now for each of them you need to solve. For S1, S2, S3, S4, S5. For each of them you will have to calculate A dot ds. So let's get started for S1 first. S1. For S1 I need to calculate A dot ds. For S1 I am doing. For S1. What is the value of A? And what is the value of ds? Both I need to write down. For S1 the value of ds is dx dz minus j cap. And value of A is x I cap plus y j cap minus 2z k cap. X I cap plus y j cap plus 2z k cap, and for S1 the value here is dx dz minus j cap. Dx dz minus j cap. Don't mess up the direction. Dx dz minus j cap. So basically dot product is there, so j cap will be multiplied with j cap only. So what you will be getting? For S1 I am getting, sir, minus sign will be there, minus sign you will be getting minus y dx dz. Minus y dx dz. This is what you will be getting. This is what we are supposed to calculate. So now you see the surface. You see the surface. Where is the surface? I again make the S1 surface. I am again making the S1 surface here. Again and again, same surface I will have to make. This is the surface that I have made. What was this point? The equation of this was x square plus y square equals to 4. Here the equation was x square plus y square equals to 4. So that means if x is 2, y is 0. If x is 0, y is 2. And what about z value? Here the value of z is 0. Value of z is 0 only. Now what about this point? Sir, here value of x is 2, value of y is 0, but the value of z is 5. Value of x is 0, value of y is 2, value of z is 5. These are the coordinates, right? So all these coordinates you already know. These coordinates you already know. 0, 0, 0. This is x, y and z. Now in xz plane we are supposed to calculate. So I need to put the limit of x and z. So from where to where the limits are going. What is the value of y here? Value of y is 0. Value of y is 0. Is that correct? On this plane. On this plane, what is the value of y? On this plane, what is the value of y? The value of y is 0. You are calculating the surface integral. Surface integral. On this surface, I was thinking that I will put the limit of x and y, but on this surface, what I got to know? The value of y is 0, no? So 0 dot dx dz. What is the answer? 0 only. Only for S1 surface you are calculating. Or you are on the S1 surface. On the S1 surface, the value of y is 0 itself. Here it is coming out to be dx dz minus j cap. minus j cap will be multiplied by minus j cap because I cap j cap will be 0, j cap will be minus 1 because minus sign is there, and k cap j cap will also be 0. So minus y dx dz, minus y dx dz, y value is 0 only, answer is 0. For S1 it is 0. For S2, what you will be getting? A dot ds for S2 surface, x I cap plus y j cap plus 2z k cap. What will be the scenario? This was your S2 surface, no? This was your S2 surface. So what is the scenario? Coordinates and everything I will be able to write down, but first you will write down the area vector. That was dy dz, and what is the direction? Dot product is there. What is the direction? Direction is minus I cap, right? Direction is minus I cap. So from here what you see, for S2, minus sign will be there, I cap will be dot product with I cap, so minus x dy dz. What is the value of x here? What is the value of x on this plane? When you are moving on S2 plane, what is the value of x? So the value of x is 0. So what is the answer you will be getting here? 0 dy dz, 0. For S1, S2, it is coming out to be 0 only. Let's check for this was your S2. Next, what we will check for? Next, we will check for S3 and S4. S3 and S4. These are our S3 and S4. So let me take this diagram only, and I will simply copy this diagram there. Okay, so next is A dot ds you are supposed to calculate S3. What is the value of A? X I cap plus y j cap plus 2z k cap. X I cap plus y j cap plus 2z k cap. Dx dy k cap. Because for S3 I am talking about. For S3, what is my surface area vector? So dx dy k cap, right? So what you are getting? I cap k cap will be 0, j cap dot k cap will be 0, k cap dot k cap will be 1. So 2z dx dy. This is what we are getting. 2z dx dy. Now on this surface, on S3 surface, what is the value of what is the value of z? Here the value of z is 5, no? Here the value of z was 0. I hope you have seen the cylinder. Cylinder is going from 0 to 5. 0 to 5. The cylinder question, in the question you can see that cylinder is going from 0 to 5. So value of z is 5 here. Value of z is 5 here. So value of z is 5 here. So double integral value of z is given as 5. So 5 into 2, answer will be 10 dx dy. What is the meaning of dx dy here? Simply the surface area of this. What is the radius? What is the radius? Radius is x square plus y square. What is the equation of this circle, which is x square plus y square equals to 4? This was the equation, right? X square plus y square equals to 4. So what will be the radius? Radius is, what is this length? This length is nothing but 2. What is this length? This length is nothing but 2 length. So what will be the surface area? The surface area will be nothing but pi r square by 4. Pi r square by 4. Right? So 10 pi by 4 r square 2 square. Answer is 10 pi. So from the upper surface 10 pi flux is going on. Like what you can see, from S1 surface 0 flux is going on, from S2 surface 0 flux is going on, from S3 surface 10 pi flux is going on. 10 pi flux is going on. From S4 surface how much flux is going on? Let's check that out. From S4 surface, sir, A dot ds I am supposed to do. Sir, again the same thing I will be writing down, dx dy k cap. Sir, again the same thing I will be getting, just with the negative sign. Say yes or no? Sir, again the same vector. This time, sir, my surface area vector is dx dy minus k cap. Dx dy minus k cap. So 2z dx dy. But there will be a negative sign for S4. Now at S4, what is the value of z? Sir, at S4 the value of z is 0. The value of z is 0. At S4 the value of z is 0. So what you understand, sir, from S1 surface the flux passing is 0, S2 flux passing is 0, from S4 flux passing is 0, from S3 the flux passing is 10 pi. Till this point is it clear? Absolutely clear. Now from the curved surface we need to find out. From the curved surface how much flux is passing? From which surface? From the curved surface, which is this one. From this particular surface how much flux is passing? This is what I am supposed to find out. Have I written the surface area for this? Absolutely, sir. I have surely written the surface area for this. Again, let me add pages. Too many pages I will have to add. Now you would be thinking that, sir, how I will be solving this question in the examination hall? There is a technique for this, okay? There is a technique which we will be using later on, okay? So I will tell you a simple formula that you can use. But as of now, we are doing it comprehensively. So ds vector we have already written. What that ds vector came out to be? So the ds vector was having a bit of longer formula, which was xi cap plus yj cap divided by x dy dz. Xi cap plus yj cap divided by x dy dz. So this was the surface area vector that I was getting. Okay. What I am supposed to calculate? For S5 surface A dot ds. A dot ds. What is A? Xi cap yj cap 2z k cap. Dot product with xi cap plus yj cap divided by x dy dz. Dy dz for S5. Dy dz. Okay. Now x square plus y square divided by x dy dz. This is what we are supposed to calculate. S5, right? You can do the calculation x square plus y square divided by dz. On this surface, what is the value of x square plus y square? Everywhere on this surface, sir, the value of x square plus y square is always 4. On this surface, the value of x square plus y square is, sir, always 4. So this can be converted into, on S5 surface, sir, it is always 4 dy dz. Now, sir, I am supposed to put the limit of y and z. Y and z. Supposed to put the limit of y and z. Right? What does that mean? That means I need to put the limit of y and z. That means I will take everything on yz plane. I will take everything on yz plane. Say yes or no. I hope you are able to understand. What will be the projection of this on yz plane? It will become a rectangle. I need to take like dy dz. I need to put the limit of y and z. That means on yz plane, how it will look like. So how it will look like? I need to put the limit of y and z. That means I need to go to yz plane. So on yz plane, what will be the scenario? On yz plane, that scenario would be that it will look like a rectangle. And if you need to put the limit, you would know that what is this coordinate? This coordinate is 0, 0. And what is this coordinate? X equals to 0, y equals to 2. X equals to 2, y equals to 2. YZ coordinate we are writing down, although you are able to understand, no? Like YZ coordinate, y equals to 0, z equals to, this is what we are writing down, that y is 0 here and z is 0. Y equals to 0, z equals to 0. This is what I have written here. Y equals to 0 and z equals to 0. Then y equals to 0, z equals to, sorry, z equals to 0, y equals to 2. Coordinates and all, it is not that difficult, although here 0, 0, 0, x, y, z all 0. Here x is 0, y is 2, z is 0. X is 0, y is 2, z is 2. X is 0, y is also 0, y is also 0, z is 2. You need to put the limit. What you will do, you will take a strip. You know that, sir, y is going from 0 to 2, x is also going, z is also going from 0 to 2. Y is going from 0 to 2, z is also going from 0 to 2. Is that clear to you? Some guy would be thinking that, sir, let's put x equals to 0 because, sir, you are doing the calculation on yz plane, no? On yz plane, sir, the value of x is 0. Here the value of x is 0. Why you went to yz plane? Because you need to put the limit of y and z. You are doing the calculation on S5. Calculation is going on S5. You went to yz plane for the limit of dy dz. Like I need to put the limit of y and z. Sir, I was not able to understand, sir, how the y and z are moving. So what I did was I took the projection. So you went to yz plane for the limit of dy dz. It doesn't mean that here on yz plane surely x equals to 0. But calculation is going on S5. No, calculation is going on S5. On S5 x is not 0. X is varying there. Are you able to understand what I am saying? A very important statement. On S5 plane, on this S5 curvature, on this curved surface, is the value of x 0? No. So calculation is going on S5. Right? Why you went to yz plane? To take the limit of y and z. That's it, nothing else. For putting up the limit here, you went to yz plane. Here someone would say that, sir, you have put the value of y equals to 0 here. When you are on S1 plane, no, so you have put the value of y equals to 0. Because you are doing the calculation on S1 plane, no. Here the calculation is going on S1 plane, no. The calculation, you are doing the calculation for S1 plane. And on the S1 plane, sir, y equals to 0. On the S2 plane, sir, x equals to 0. That's why I put it. But here, on S5 plane, x is not equals to 0. The calculation is going on S5 plane. The projection you took just for the limit purpose. Your surface, this is not your surface, not your calculation surface, not your surface. You took this projection only for the limit purpose, so that I will be able to write down the limit. Are you able to understand this point? So on the surface S5, what is the value of x? So the value of x is here x square plus y square equals to 4, right? So the value of x could be written as under root 4 minus x. And why I am writing down the positive under root? 4 minus y square. Positive under root because everything is happening in the first octant. So under root 4 minus y square dot dy dz. This is what I can write down. And the limit of y is going from 0 to 2. Limit of y is going from 0 to 2. And limit of z is also going from 0 to 2. This calculation I am supposed to solve now. Is that understandable to you? What calculation I am supposed to solve? That y and z both going from 0 to 2. Y and z both going from 0 to 2. 4 divided by under root 4 minus y square dy and then dz. Okay. So do we know the answer of this calculation? It is sine inverse x by a square minus x square, sine inverse x by a. So z going from 0 to 2, 4 is outside, sine inverse x by a, sine inverse y by a. Value of a square minus, like, do you remember this formula? 1 upon under root a square minus x square dot dx. That is nothing but sine inverse x by a. This formula I am applying. Sine inverse y by a, y by 2. Okay, 4 is constant value that I am taking outside with limit going from 0 to 2 dot dz. Is that clear or not? Have I applied it correctly? 4 outside, sine inverse y by 2. Yeah, everything is correct. So what you are getting, sine inverse 1 is pi by 2 only. So 2 pi. अबे यार कहाँ गलत चला गया भाई? Where things went wrong? So 4 sine inverse 1. What is the value of sine inverse 1? Sine inverse 1 is pi by 2. Right? Dot dz with z going from 0 to 2 again. Let me recheck the calculation again. Yeah, sorry for the interruption. The very big blunder I did here, that z is going from 0 to 5. No, this will be z equals to 5 here. Limit of z is going from 0 to 5. This was the cylinder. You check the cylinder. Z is going from 0 to 5. So this was a big blunder from my end. Z is going from 0 to 5. Z is going from 0 to 5. So limit of z will be from 0 to 5. limit of z is going from 0 to 5, 0 to 5, 0 to 5, 0 to 5 here. So limit of z is going from 0 to 5. Limit of z is going from 0 to 5. So what will be the answer here? 2 pi, then z answer is coming out to be 10 pi. Okay. So flux through different surfaces we have seen. Flux through S1, S2 and S4. What was that? 0. And flux through S3 was 10 pi, right? Flux through S3 was 10 pi only. Through S3 it was 10 pi, and through S5 as well it is 10 pi only. So what will be the total flux passing? So total flux passing A dot ds, right? A dot ds. A dot ds is coming out to be total flux passing A dot ds. Why I am putting this circle here? Because it is closed line integral. That is coming out to be what? 10 pi plus 10 pi, 0 plus 0 plus 0, 0 plus 0 plus 10 pi plus 0 plus 10 pi. Total answer is 20 pi is the total flux that is passing. That's the answer. So this kind of lengthy question are we going to solve in the examination? This much calculation, sir. This question was given, sir. This much calculation. What was the question given? This was the question given. How would I solve in the examination? This question is given. What I am supposed to calculate? The total flux I am supposed to calculate. I know that, sir. I am supposed to calculate A dot ds. Now you know that a closed surface will enclose some volume. A closed line was enclosing some surface area. So there was a method for that. There was a separate method for that. Now you know that, sir, a closed will enclose some, a closed surface will enclose some volume. A closed surface will enclose some volume. It will enclose some volume. So there will be a separate formula for this one as well. There was a formula for A dot dl, no? For a closed surface, for a closed line. For a closed line, sir, there was a different formula. What we did? Del cross A dot ds. And whatever the surface area it was enclosing, I find out the surface integral. I find out the surface integration on that particular surface only. So similarly here, sir, I need to find out the surface integration, but it is enclosing a volume. So sir, this will be equivalent to del dot A dV over the volume V. That's it. So what you do is that you calculate del dot A first. Can you calculate the divergence of this? Yes, sir. Partial definition of x 1, partial definition of y 1, partial definition of 2z 2. Del dot A is coming out to be 4. 4 dot dV. 4 not dot. It is not dot. It is a scalar number. This is also a scalar number. 4 dV. For the volume V. How much volume it is enclosing? Sir, this length is 5. This length is 5. And what is the radius? Radius is 2. Right? And what will be the surface area? Like, can you do you know what is the surface? What is the volume of a cylinder? So that is pi r square h. Why it is pi r square h? Because, sir, this surface area is pi r square. So pi r square is stacked for height h. Pi r square has been stacked for height h. That's why the surface area is pi r square h. That means pi r square is added h times. So similarly, what is this surface area? Sir, this surface area is the 4 times. This surface area is, sir, pi r square by 4. So pi r square by 4 added 5 times. So what will be the surface area? The surface area will be nothing but pi r square by 4 added 5 times. Pi r square by 4, pi r square by 4, pi r square by 4. How this formula came? Pi r square multiply with h. For a cylinder, how the formula came? Sir, for this cylinder, sir, the formula came. The surface area, the area of the base was pi r square. The area of the base was pi r square. And then, sir, height was h. What this is representing? First of all, you let me know what this is representing. This is representing the total volume. Right? This particular thing is representing the total volume. So I am supposed to find out the total volume. But this time I am not having a full cylinder. It is the cylinder in first octant only. So the area of the base is pi r square by 4, pi r square by 4 added with height h. Here it was the scenario pi r square added with height h. So pi r square h. Here pi r square by 4 stacked for height h. So pi r square by 4 multiply with 5. So what answer we are getting? 5 pi r square. What is the value of r? That is 2. 2 square. What is the answer we are getting? 2 square will be 2 square will be 4. So 20 pi is the answer we are getting. That's it. This is how I could have solved in the examination hall. Within seconds I would get the answer. I would have directly thought that a dot ds from here, del dot a would come out to be 4 dot dv. I should not say dot dv, it is simple multiplication. dv it will simply represent the volume. What is the volume of this cylinder? That will come out to be pi r square by 4h. So sir, volume would come out to be, whatever the volume is coming out to be, I will simply multiply with 4, answer will be 20 pi. Volume is coming out to be 5 pi, 5 pi multiply with 4, answer is 20 pi. Understandable? Job done. Okay, so this is how I will be able to solve it. The same kind of question we can solve. Another question we can solve. What we can do is that the same kind of question, let's just say one more this kind of problem we are going to solve. Let's solve this question. Okay, let's solve this question. Vector A is given, find out the total flux through the closed surface x square plus y square plus z square equals to 4. What this is? This is a sphere of radius 2. Sphere of radius 2. What they are asking you to find out? Through the closed surface. What they are asking you to find out? Flux. That means they are asking you to find out flux through the closed surface A dot ds. That will be equals to del dot A dv. Dot dv not. Del dot A dv. So what is the value of del dot A? Del dot A is 3. 3 dv with the volume v. 3 comes outside. dv. What this represent? This represents the volume. This represents the volume. What is the volume of the sphere? Volume of the sphere, that I hope you know. Volume of a sphere is 4 by 3 pi r cube. Right? 4 by 3 pi r cube is the volume. So from here you will get the answer. 4 pi, value of r is 2 cube. 32 pi is the answer that you will be getting. 3 into volume, that will be 32 pi is the answer. So total flux will be 32 pi. What is the meaning of flux? Number of field lines. How many number of field lines are passing? So 32 pi field lines will be passing. Okay. So volume 4 by 3 pi r cube. So from here you get the answer. Okay. Value of r you put 2 only because radius is 2. I hope you know the radius. I hope you know the equation of sphere as well. So radius is 2. So answer is 32 pi is the answer. Okay. So this is known as divergence theorem or Gauss theorem, you can say. This particular theorem was Gauss theorem or divergence theorem. Gauss theorem. Okay. So this is the Gauss theorem. The total outward flux of a vector field f through a closed surface S is equal to the volume integral of the divergence of the vector field over the volume V, enclosed by the surface, provided the vector field f is continuous throughout the volume. The same condition is there. Vector field f is continuous throughout the volume. The same condition is there. Whichever the condition was there in Stokes theorem, the same is here as well. Okay. Just remember f dot ds equals to del dot f dv. F dot ds del dot f dv. Okay. Now, what do you think? What is the meaning of divergence then? What do you think? What is the meaning of divergence? So, what is this? This is the flux. So, divergence is nothing but flux per unit small volume. So, it is divergence of a vector field represent the net outward flux per unit volume as volume approaches 0. Total flux per unit volume. That's it. So, divergence, meaning of divergence is simply total flux per unit volume. This is the meaning of divergence. So, what kind of question could be asked? Which of the following statements are true? The gradient The direction of gradient is always towards the maximum rate of change. Correct. Curl. Maximum circulation per unit surface area would represent the curl. Correct. Flux per unit volume will be represented by the divergence. Total flux passing per unit volume will be represented by the divergence. That is also correct. So these kind of statement wise question could be asked. That's why I have written the physical interpretation of divergence. Do we know about the sign? Yes sir. If it is diverging, positive. If it is converging, negative. That we already know. Right? Now till this point in this lecture, what we have seen? Open line integral A dot dl. No theorem is there. Directly you need to work through the line P to Q, Q to R in that manner. Now closed line integral A dot dl, it could be replaced as del cross A ds, right? Where S is the surface area enclosed by closed line integral. S is the surface area enclosed by closed line. For A dot ds, there is no method. Open surface, there is no method. For open surface, we have solved the question for open surface. No, which question we solved? For open surface, this was the question for open surface. This was a open surface only. For open surface, there is no method. ds you find out. Complete process you follow. Put up the limit of xy. Everything you get the answer. Right? Now someone would say that sir, here on this surface as well, on this particular surface as well, sir, z was not 0. On this surface, when you are, let's just say this surface is surface S. On this surface, sir, z is not 0. So here I am not putting z equals to 0. Z is getting cancelled out here. Let's just say if in place of this z, if it was 2z, let's just say in place of this z, if it was 2z, then what I would be getting? 3x plus 2y plus z. 3x plus 2y plus z dx dy. Then will I be saying that since I am working on xy plane, so I will be putting up z equals to 0? No. You are coming on the xy plane to put the limit of x and y, but you are working actually on this plane. And on this plane, what is the value of z? The value of z is 4 minus x minus y. So I would have put here 4 minus x minus y. Is that understandable to you? So this is a very important point. That you are coming on xy plane doesn't mean z is equals to 0. You are coming on xy plane for the limit of x and y. But you are actually working on this particular plane. And on this particular plane, the value of z is 4 minus x minus y. So here I can put 4 minus x minus y dx dy and I can put the limit. Luckily here z and z got cancelled out. Is that understandable to you? Okay, so this was a very important point that we have seen in one of the question. That for the sake of limit here, for the sake of limit, you are coming in yz plane. Doesn't mean that here your x will be 0. You are actually working on S5 curve. And on S5 curve, or you can say on S5 surface, x is not 0. The value of x is under root 4 minus y square. That we have put here. Is that clear to you? Everything is clear to you? So we solved here open surface integral we have solved here. So for open surface, there is no technique. You need to find out the answer completely. Complete answer you need to find out. You need to find out the ds vector as well. And in future, this kind of question is coming that I am telling you. Then we saw for closed surface. Then we saw one by one, S1, S2, S3, S4, one by one with patiently, with good amount of patience, we have understood everything. And then what we saw? We saw the theorem. What is that theorem? That theorem simply say A dot ds equals to del dot A dot dv. Okay, so del dot A I will calculate. Then simply volume I can calculate on my own. Understandable? So this is the scenario. Similar question we saw here as well. Now it is not necessary, no, that always it will come out to be like this only. Let's just say I calculated del dot A and it came out to be 3x. Del dot A I calculated, this I calculated, it came out to be 3x. Then what you will do? 3 you can take outside, double integral, triple integral x dv. So that could be put as 3x dv could be dx dy dz. Now I need to put the limit of x, y and z. I hope you know how to solve this kind of integration as well. In the multiple integral we have studied it. First I will go and take the limit of z. Z is going from this to this. Then z would be gone. And after that I will put the limit of x and y by coming in the xy plane. Everything we have understood, right? All these things in detail we have discussed. These kind of questions we are going to solve in the next lecture. Okay, but I am already telling that this kind of scenario is also possible. Here luckily 3 came out, already it was becoming volume only, got your answer. But it might happen that x is left here. So what you need to do now? Now you need to take the limit of x, y and z. First you would take the limit of z, then you would come on xy plane, you would take the limit of x and y as well. I hope you remember it. Okay, then this we saw. And now for closed line integral, what we have seen, sorry, for closed surface integral, what we have seen, del dot A dV with volume V here. Okay, what is the volume V? Volume V is the volume enclosed by the closed surface. Volume enclosed by closed, volume enclosed by closed surface. Yes or no? Is that clear to you? Okay. So mostly conceptual part is completed here. We are solving the problems only. There is nothing concept here. Questions only we need to solve. With respect to question, we are understanding everything. So conceptual part is completed. Now a very specific type of question we are going to discuss. Very specific. What kind of specific type of question? In the examination, they would ask you del cross f dot ds, del cross f dot ds, and they will mention f. Del cross f dot ds they will ask, and it will be, the surface will be hemisphere. Is it a closed surface? Anywhere did they write down it is a closed surface? No. Nowhere it is mentioned that it is a closed surface. So let's just say this question is coming, you need to solve this question in the examination. So try solving this question, but it is a very specific pattern. So from this pattern you can conclude something. What you can conclude, that we will see, but as of now you treat it as a separate question and try solving it. Can you draw x square plus y square plus z square equals to 1 with z greater than 0? Can you draw it? Sir, this is the equation of sphere. But sir, z greater than equals to 0 I need to take. What I mean to say is that equation of sphere is x square plus y square plus z square equals to 1. This is the equation of sphere. This is your sphere. But sir, since only z greater than equals to I need to take, that means this was your sphere, right? This was your sphere. This is the sphere. This is the part of z greater than 0. This is the part of z less than 0. You need to take only the part of z greater than 0. That means only the upper part you need to take. So only the upper part you need to take. So now sir, this will become hemisphere. This will become hemisphere. This much was sphere, this would become hemisphere. So now what you can see? What kind of diagram you would be getting? तो भाई इधर जा. Note the full sphere, hemisphere I will be getting, no? So how do I make the hemisphere? What I do? This is your xz plane actually. This is your z. This is your x, y. Z greater than 0 I need to take. So wait a second. Let's keep this as z. This is x and y. Z greater than 0 I need to take. Right. So this is how I can make the hemisphere. This is the hemisphere that I have made. Right. This is the hemisphere. I hope you are able to understand. Here your z equals to 0. And the upper part is z greater than 0. Here what will be the value of z? Z will be equals to 1 here. X square plus y square equals to 0, no? Here the equation of the circle is x square plus y square equals to 0, so z will be equals to 1 here. Here z is equals to 1. Right? So only through this surface you are supposed to find out. Only through this surface you are supposed to find out, not through the downward surface. Are you able to understand this point? Only through this surface you are supposed to find out. Only through this curved surface you are supposed to find out. What you are supposed to find out? Del cross f dot ds. So what is your surface now? This is your surface. This is your surface S. This is not the downward surface you cannot take. So it is an open surface. It is a open surface. It is a open surface. So for this open surface, I will have to write down the ds vector, which will be a difficult task. So first let's calculate del cross f. First my target is, let's calculate del cross f, because what I am supposed to calculate? I am supposed to calculate del cross f dot ds. This is what I am supposed to calculate. So first I need to calculate del cross f. So what is the answer of del cross f I am getting? I cap, j cap, k cap, del by del x, I cap, j cap, k cap, del by del x, del by del y, del by del z. Z x y, z ax cap, ay cap, az cap, z x y, z x y. What answer you will be getting? I cap 1 plus minus j cap 0 1 minus 1 plus k cap 1. This is what you are getting, right? For I cap 1 minus j cap minus 1 and then k cap. This is what you are getting. You are getting I cap plus j cap plus k cap. This is the del cross f you are getting. Let's call this as a new vector, vector A. So this could be replaced as over the surface as A dot ds I am supposed to calculate. Okay, and that is coming out to be I cap plus j cap plus k cap dot ds vector. So now you are supposed to calculate the ds vector. This is what I am supposed to calculate. Now on this particular surface, for this surface, what is the equation? The equation is x square plus y square plus z square equals to 1. X square plus y square plus z square equals to 1. Right? So what I can do? I can treat these as free and this as fixed. Right? What does that mean? My ds would be written as under root 1 plus zx square plus zy square dx dy. What will be the value of z here? Since z is positive, z is greater than 0, so I can take z equals to positive under root 1 minus x square minus y square. So what will be the value of zx you will be getting? Minus x upon under root 1 minus x square minus y square. Similarly, zy also you can write down. So what answer you will be getting here? Under root 1 plus x square upon 1 minus x square minus y square plus y square upon 1 minus x square minus y square dx dy. So what you are getting? One minus x square minus y square plus x square plus y square. What answer you are getting is 1 upon under root x square under root 1 minus x square minus y square dx dy. Now you let me know what is this 1 minus x square minus y square. So that this is nothing but z only. This is nothing but z only, no? This is z only. But let's keep it 1 upon under root 1 minus x square minus y square only. Let's keep it in this manner only. Okay? Although it is z. So this is your ds. What about ds vector? Did I ask you to directly remember it for a sphere? For a sphere, did I ask you to directly remember? If I write down that ds cap, if I need to write down the ds cap, what I will do? I will make a function phi which will look like x square plus y square plus z square minus 1. So first I will take the gradient. That will come out to be 2x I cap plus 2y j cap plus 2z k cap. Then I need to find out its direction. This direction would be same as ds cap. 2x I cap plus 2y j cap plus 2z k cap divided by under root 2x whole square plus 2y whole square plus 2z whole square. So 2 comes outside, so this will come outside. X square plus y square plus z square. So what you are getting? 2 and 2 will get cancelled out. X I cap, I directly asked you to remember this. X I cap plus y j cap plus z k cap divided by under root x square plus y square plus z square. What is the answer you will be getting? That is 1 only. That is 1. So what you are getting? X I cap plus y j cap plus z k cap. This is your ds cap. So what is your complete ds vector? So ds vector completely is coming out to be 1 by under root 1 minus x square minus y square. Okay. X I cap plus y j cap plus z k cap dx dy. This is the scenario. This is the ds vector you are getting. Now what you are supposed to calculate? You are supposed to calculate del cross f dot ds, which will be equivalent to a dot ds. That will be equivalent to surface area S. Now what is A? A is I cap plus j cap plus k cap. I cap plus j cap plus k cap. Dot product with x I cap, y j cap, z k cap, because ds vector I am writing down, divided by under root 1 minus x square minus y square dx dy. So I cap will become x, j cap will become y, k cap will become z. So eventually what you are getting? Eventually we are getting is x plus y plus z upon under root 1 minus x square minus y square dx dy. This is what we are supposed to calculate. Dx dy, sir. Dx dy. That means now I need to come on the xy plane, right? What does that mean? I need to take its projection on xy plane. If I need to put the limit of x and y. So sir, can I put z equals to 0? Can I put z equals to 0? No, this will be wrong. Why is that so? Because your calculation is going on surface S. Calculation is going on surface S, and on the surface S, z is not 0. It is varying here. So you cannot put z equals to 0. You are coming on xy plane only for the purpose of these limits, nothing else. Are you able to understand this point? On the surface, what is the value of z? The value of z on the surface, the value of z is under root 1 minus x square minus y square, and this only you have to put. This only you have to put. Is that understandable to you? Okay. So you will come on xy plane. You will come on xy plane. So on xy plane, what you will get? Let's make xy plane only. On the xy plane, if you take the projection, you already know that, sir, what I will be getting? I will be getting a circle. Circle, the equation of circle will be x square plus y square equals to 1. X square plus y square equals to 1. X square plus y square equals to 1. This on xy plane, this is what I will be getting. The equation of this circle will be x square plus y square equals to 1. So on that manner, I need to put the limit. So what is my integral? Integral is looking somewhat like this: x plus y upon under root 1 minus x square minus y square dx dy, plus for the same surface S, z upon, which is z upon under root 1 minus x square minus y square dx dy. Why I put it separately? The answer of this particular integral over this surface S. What is your surface S? This is your surface S now. I should not say surface S, I should write down region R here. Region R here. Why I am writing down region R here? Why I am writing down region R here? Because now you are putting the limit of x and y based on this region. Based on this region R. Right? You are putting the limit of x and y. How will you put the limit of x and y? Sir, this point will be minus 1, 0, and this point will be 1, 0. Someone would say that, sir, I will solve in the polar coordinate system. Everyone would solve in the polar coordinate system only. Try solving this particular thing in the polar coordinate system. You would realize that answer is coming out to be 0. And without even solving, I can say that answer will come out to be 0. How I can say? Let's solve it. Okay. Polar coordinate system we will solve. On this particular surface area, x equals to r cos theta, y equals to r sin theta. So what you will get? X equals to r cos theta, y equals to r sin theta. So r you take common, x plus y you are doing, divided by under root 1 minus r square, divided by under root 1 minus r square. Multiply with dx dy would be r dr d theta, r dr d theta, with the limit of r going from 0 to 1 and with the limit of theta going from 0 to 2 pi. Now just notice one thing: if I don't even solve this r term, I am only solving this integral. Even if I don't solve this r term, what is the r term? R term is r square divided by under root 1 minus r square. If I only solve the limit of theta, cos theta is going from 0 to 2 pi. What is the area of 0 to 2 pi cos theta? Answer would be 0 only, no? Forget about the limit of r. First you solve the limit of theta. What limit of theta is saying? Theta is saying that I am going from 0 to 2 pi. Integral of cos theta will be 0. Integral of sin theta will also be 0. What will be the total integral? It will come out to be 0 only. So this integral will come out to be 0 only. Directly I could have said so. Why is that so? What you are calculating? You are calculating f of x comma y dx dy over the region R. Now in this region R, you already know that, sir, it is symmetric about origin. It is symmetric about origin. Symmetric about origin. It is symmetric about origin. Symmetric about origin. All these kind of things we have studied in the integral calculus. Since it is symmetric about origin, so in place of x, if you put minus x, in place of y, if you put minus y, what you are getting in this function? In place of x, if you put minus x, in place of y, if you put minus y, downward it would be same only, since it is. So what you are getting? Minus x plus y divided by under root 1 minus x square minus y square. What you are getting? So this is coming out to be equals to minus f of x comma y. And if this is the scenario, then this integral will always come out to be 0. If your region R is symmetric about origin, if your region R is symmetric about origin, is it symmetric about origin? Yes. Then in fxy, if you put in place of x, if you put minus x, and in place of y, if you put minus y, then what you realize is that f of minus x minus y is coming out to be minus of f of x. It is coming out to be minus of f fxy. Then what you would see, the double integral f x comma y dx dy would come out to be 0. Why is that so? You can relate it with the odd function. For an odd function, if I calculate from minus a to a fx dot dx, what will be the answer? 0 only. Because for an odd function, f of x equals to minus of fx. So similar thing I am doing here. In place of x I am putting minus x, in place of y I am putting minus y. What I am calculating? I am getting the answer to be 0. Here calculation I have done, answer is coming out to be 0 only. So this would be 0. Without even picking up the pen, I would say it will be 0 only. What will be this scenario? What will be this scenario? What will be the answer of this scenario? So simply copy it. I simply need to calculate this scenario now. What answer I will be getting? Region R. So z is under root 1 minus x square minus y square upon under root 1 minus x square minus y square. Why I am writing down z as this? Because I know that, sir, my matter of concern, when I am putting s here, my surface is the sphere. This is my surface. Surface is sphere, and on the surface z is not 0. Here, sir, why I am moving to xy plane? Only for the limit purpose. So only for the limit purpose I have moved. So what I am getting? I am simply getting the area of this xy plane, which is coming out to be pi r square only. This area is nothing but pi r square, right? Pi into r into pi r square. What is the radius? Radius is 1. So pi r square. This area will be pi r square. So this is the answer that we are getting. This integral is pi only. And this is what we were supposed to calculate. All the calculation, after doing everything, what we are getting is that, so del cross f dot ds is coming out to be pi. This is how this question was supposed to be solved. Will you be able to solve it in the examination hall? This is a gate PYQ. Gate PYQ. In the exam hall, will you be able to solve it in this manner? Absolutely not. Right? I will not be able to solve, sir. How will I solve that? Sir, it feels like that, sir. Del cross f dot ds. Stokes theorem we have studied, no, sir. F dot dl. F dot dl. Sir, F dot dl will be equals to del cross f dot ds. So what is this surface as? What is this surface as? If you go to the previous page, what is the surface as? Surface S is, here if you apply this, surface S is the surface enclosed by the closed line. Which closed line? This surface, this is the surface, no? You are having this surface. This surface is enclosed by which closed line? Which closed line you will talk about? Like if you are moving on this surface, that means there are a lot of closed lines. No, a lot of closed lines are there. So are you able to determine this curve C? This is the problem, no, sir. What I thought was, sir, they are asking del cross f dot ds. I thought that I will solve for f dot dl. What is the curve C? Which curve C you will take? What is your closed curve C? What is your closed line C? Can you determine the closed line C? We have applied this theorem. No, we have applied this theorem in one of the previous questions. In this question, we have applied this theorem. What was the closed curve C? This was the closed curve C. Am I able to see the closed curve C? Yes, sir. Am I able to see the surface area? Yes, sir. Completely. In this question, you let me know what is your closed curve C. Where is your closed curve C? Can you determine that closed curve C? No. So I am stuck here. The only option that was left for me was that you calculate in this manner, that you calculate the ds vector. You calculate the ds vector in this manner. First of all, it will take a lot of time. And after that, you do this calculation, you calculate del cross f, then you do this calculation, then you use so much of your brain that this will come out to be 0, z upon under root x square minus y square, this will come out to be simply equals to the area. Answer is pi. This much you do. Here we noticed another interesting thing. What we noticed? That whatever the answer that you are getting for the upper part of hemisphere, no, for the upper part of hemisphere, whatever the answer that you are getting for the upper part of hemisphere, the same answer you get for the lower part of hemisphere as well. What I mean to say, first of all, here one doubt might be there, that sir, why you took only the positive side? Like other could also be possible, no, minus xi cap plus yj minus yj cap minus zk cap. This is the error from the side of question maker setter. He should have written that the surface is taken in positive z direction or positive y z direction or positive x direction. It should have been written. If it is not written, no, then we will always take positive only. So here this doubt I am clearing. Now what I was saying, that sir, there are two surfaces. This surface was there. In the examination, the flux through this surface was asked. I should not say flux, through this surface del cross f dot ds was asked. This was asked in the examination. Del cross f dot ds through this surface was asked. But sir, in this hemisphere there is another surface, no? Although they did not ask anything about this particular surface, they did not ask anything about this surface, but let's try doing one thing. I will try to calculate the flux through this surface. Flux through this surface, or I will try to calculate del cross f dot ds through this particular surface. Can I try doing it? Let's try doing it and let's see what answer we are getting. Del cross f dot ds through this particular surface, which is in the xy plane. So let's make the surface in the xy plane. So here I am writing another method. For another method, what I am doing, this time I am trying to calculate. First of all, I am going to draw the surface. What is my surface? My surface is in the xy plane only, which is simply a circle now. So for this particular surface, I am going to calculate del cross f dot ds. For this surface, okay, this is my surface S now. This is not the region R, I am talking about surface S. So for this surface S, what I am going to calculate? For this surface S, I am going to calculate del cross f dot ds. Now let me know, can you write down the ds vector very easily? Yes sir, ds vector very easily I can write down. Dx dy. Now someone would say that sir, two directions are possible, plus az gap minus az gap. Yes, both are possible. Should have been mentioned in the examination that it is talking about plus az direction, but since it is not mentioned, we will take plus k cap only. Okay, it should have been mentioned actually, but we will take plus k cap now. So ds vector is dx dy k cap. Now what was your del cross f? What was the answer of your del cross f? Del cross f dot ds. What was the answer of del cross f? Del cross f answer was, sir, del cross f was I cap plus j cap plus k cap, right? Del cross f we calculated, it came out to be I cap plus j cap plus k cap. I cap plus j cap plus k cap. What is the ds vector we are getting? So dx dy k cap only. Dx dy k cap only. Dot product you can do. What answer you got? I cap k cap 0, j cap k cap 0, k cap 1, dx dy over the surface. What is it is representing? Pi r square only. Within seconds you got the answer. Within seconds you got the answer. But sir, here as well I need to calculate the curl, right? In the examination, this process you will have to do. So what did you notice here is that if I make a hemisphere, or let's copy the same hemisphere here. If I copy the same hemisphere, if I take the same hemisphere, then what do I notice? Let's just say this hemisphere is having two surfaces. This hemisphere is having two surfaces, which is this surface is S1, upper surface is S1, for any kind of hemisphere, let's not label it. This is a random hemisphere. This surface is S1 and this surface is S2. Downward surface is S2. I can use a different color of pen. Downward surface is S2. Okay. So for a hemisphere, you would always notice one thing. What would you notice? That sir, for any vector field, dial cross f dot ds if you want to calculate. Dial cross f dot ds if you want me to calculate. So either you calculate it from surface S1 or you calculate it from surface S2, both will always give me the same result. That means if they are asking from the upper surface, I would know that sir, there will be a lot of tasks. I will have to write down the surface area vector in this manner. But sir, what I would do is that they are asking from the upper surface, I would know that del cross f dot ds, whatever from the upper surface I am getting, the same I will get from the downward surface as well. But again, let me repeat, it is only true for del cross f, only true for curl, only true for curl, only true for curl of f. Very, very, very important, very important. That it is only true for curl of f, not for any random vector field. It doesn't mean that there is some random vector field you will take for S1 you will calculate and 8 dot ds for S2 you will calculate. For any random vector field, this will be wrong. Nah, they will not be correct, but they will always be same. They will always be same. They will always be same. Is that understandable to you? For S1, S2. This is the conclusion that we have made. This is the conclusion that we have made. One important point. This is your first important point. Another important point we are going to see, but this is the first important point. Have you understood it or not? Absolutely, sir. Completely understandable. That sir, if they are asking from the upper surface, dial cross f dot ds they are asking. Curl of a particular vector field dot ds if they are asking from the upper surface, what I will do, I will take its projection, I will calculate it from the downward surface. Both will be same. Now let's just say some guys would say that sir, I don't even want to calculate this del cross f. I don't even want to calculate this. What he will do in the examination then? He wants to apply the Stokes theorem, f dot dl. He wants to go with this particular scenario. What he wants to go with? He wants to go with this particular scenario. F dot dl. This is what he wants to do. Now, sir, previously he was facing a problem. Previously, he was facing a problem when we talked about the upper surface of hemisphere. When we talked about this surface, no, then he was facing a problem. Sir, what is my closed line? But I got to know that upper surface of hemisphere or lower surface of hemisphere, both are doing the same purpose. Both are serving the same purpose. If both are serving the same purpose, then what I can see that for the lower surface, for this particular lower surface, can you point out the closed line? Absolutely, sir. I can absolutely point out the closed line. I can absolutely point out the closed line. The closed line, this is your x-axis, this is your y-axis. What we started from, sir, in the examination, del cross f dot ds was given. I needed to calculate for the upper surface. Did I solve it? Completely yes, yes sir, you solved it. Then you noticed one thing that sir, del cross f dot ds, if you calculate it for the lower surface as well, no, you are getting the same answer. For this particular surface as well, you get the same answer. Now, if this was my, let's just say, if this was my curve, if this was my closed curve. Now, for this closed curve, if they were asking me f dot dl, what I could have done? I could have calculated del cross f dot ds with this as my surface area. Will it follow the same answer? Absolutely. That means my closed curve C, now this closed curve C will be nothing but a circle x square plus y square equals to 1. It will be a circular line, or you can say it will be simply a circle only. So what is my closed line now? My closed line is circle. So what you are supposed to calculate? You are supposed to calculate f dot dl for this particular circle, which is x square plus y square equals to 1. Can you calculate this? What is your f? F is given as z I cap plus x j cap z xy, z xy, z I cap plus x j cap plus y k cap. Closed line integral we are supposed to calculate. DL, in which plane are you moving? In xy plane only you are moving. So xi dx I cap dy j cap. In xy plane only you are moving. So what you are getting? I cap, so it will become z dx plus x dy in the closed surface on this line. Now can you let me know how did I take this orientation? Because I want the surface area direction to be plus az gap. That's why I took this orientation. Now when you are moving on this line, you are calculating the closed line integral over this curve C. On this particular curve C, what is the equation? X square plus y square equals to 1. And on this curve C, what is the value of z? Z is 0, no? On the curve C, we are calculating the line integral on the curve C. So on the curve C, sir, x square plus y square equals to 1, that I admit. But sir, z is equals to 0 here, no? So z equals to 0, I will put what I am getting now. X dot dy I am supposed to calculate. On the curve C, on this curve C, x dot dy I am supposed to calculate. Say yes or no. Can you do it? Absolutely. What you can do? Y equals to under root 1 minus x square you can put. In that manner you can do, or you can do with the polar coordinate system as well. How with the polar coordinate system? On this curve C, what is the value of x? Sir, value of x is usually given as r cos theta. But when you are moving on this curve, what is the value of r? On the whole curve, value of r is 1. No, on this curve, value of r is 1. And what is the value of theta? So the value of theta is varying from 0 to 2 pi. So on the whole curve, value of r is 1. That means x equals to cos theta, y equals to sin theta. Previously, sir, we used to write down dx dy as r dr d theta. Dx dy we used to write down as r dr d theta. This we used to write down for the surface. This was written for surface. Now you are talking about line. This scenario we are putting up for line. Now you are putting up the scenario for line. So r is constant here. Who is changing? Theta is constant changing. So what is the scenario? Dx would be equals to sin theta d theta. But when we used to write down dx dy as r dr d theta, so that we used to do with respect to the surface, with respect to this surface. So when I am moving on this surface, sir, r is also changing. When I am moving on this surface, sir, r is also changing, and theta is also changing. So dx dy was equals to r dr d theta. But sir, when I am moving on the line, r is constant. R is 1. Theta is varying from 0 to 2 pi. So x is cos theta. If r was 2, x would have been 2 cos theta, y would have been 2 sin theta. If r is 1, then x equals to cos theta, y equals to sin theta. What is dx? Dx is minus sin theta d theta. And what is dy? Dy would become cos theta d theta. Say yes or no. Are you able to understand all these scenarios for a particular line? X equals to r cos theta, y equals to r sin theta, and dx dy equals to r dr d theta. What we used to do for a surface, for a circular surface, surface means x square plus y square less than equals to a square. What you used to put? X equals to r cos theta, y equals to r sin theta, right? And dx dy would have been r dr d theta. And the limit of r would go from 0 to a, and limit of theta would go from 0 to 2 pi. This is what we used to do for a particular surface. For a surface, this is what we used to do. Now next, for line, what do we do? For line means, what is the meaning of surface? This is the meaning of surface. This is the meaning of surface. This is the meaning of surface, where the value of this was from here we would calculate the value of r. The value of r was going from 0 to a. Value of r was going from 0 to a. R equals to 0. R equals to a here. Value of r was going from 0 to a, and the value of theta was going from 0 to 2 pi. Now for a line, what is a line? This is a line. This is a line. Since you are at a line, now at a line, what you can see? For a line, the equation will be x square plus y square equals to a square. That means you already know that the value of x, which we used to put r cos theta, so value of r is constant here. No, on a line, value of r becomes constant. What is that? R equals to a. When you are here, This is your r equals to 0 and here r equals to a. So r equals to a is constant now. So dr is 0. But who is changing? When I am moving on the line, theta is changing. No, theta is variable. Theta is going from 0 to 2 pi. So what will be the value of x? X was r cos theta. It will become a cos theta. What will be the value of y? It will become a sin theta. What will be the value of dx? That will be minus a sin theta d theta. And what will be the value of dy? A cos theta d theta. Is that understandable to you? A similar thing we have done here. So what is the value of x? Sir, value of x is cos theta. What is the value of dy? Dy is also cos theta d theta with the limit of theta going from 0 to 2 pi. So what answer we are getting? Cos square theta d theta with the theta going from 0 to 2 pi. So cos square theta 1 plus cos 2 theta divided by 2, answer is pi. When you solve it, this will become cos square theta, right? This will become cos square theta. You can solve it, answer will come out to be pi only. Okay. More than enough integration we have done. You will solve and you will get the answer to be pi only. So answer is coming out to be pi, which is pretty obvious. Which is pretty obvious. So from all these scenarios, what did you understand? From all these scenarios, what did you understand? What did I understand is that, sir, this is something that I was having. अरे यार ये तो यहीं आ गया. What I was having, this is something that I was having. आजा भाई आजा, हैंग मत हो जाना यार. This was the scenario that I was having, and what was asked in the examination? This was asked in the examination. What was asked? What was asked? This was asked in the examination. S1 del cross F dot ds. Sir, all the analysis I did, I am doing the analysis for last 45 minutes. Then from here I go to know that, sir, even if I calculate it for S1 del cross F dot ds, sir, that would be same as even if I calculate for S2, which is del cross F dot ds. And sir, it would be same as closed line integral F dot dl for the curvature C, where the curvature C is nothing but this curvature in the xy plane, in the xy plane. Is that understandable to you or not? In the xy plane. So from this discussion you got to know that if del cross F dot ds is asked in the examination, I will directly calculate F dot dl, where the curve C will be the rim of the sphere, the rim of the hemisphere, the rim of this hemisphere. 2 to 3 times question have been asked. That's why I took this topic separately. This is known as rim of a hemisphere. What I will do is that I will take my curve C as rim of a hemisphere, rim of hemisphere, rim of hemisphere, rim of hemisphere, which will turn out to be my curve C. So in the examination they will ask for this particular surface, but what I will calculate for the rim of hemisphere, everything, all this discussion only for del cross F and only for the hemisphere. It is a very standard question. In multiple examination, multiple times it has been asked. That's why we have taken it as a separate topic. Someone would be thinking that, sir, hemisphere and del cross F, very specific. No, hemisphere along with del cross F, it is very specific, but in multiple examination, multiple times this question has been asked. Okay, answer is pi only. By 3 method we have checked. If it is wrong, then we cannot do anything. I hope this discussion you would have liked. Directly people say that you calculate, take the projection, you calculate. Doesn't make any sense, right? So to match the answer, I could have directly said that you take the projection and calculate it, but wouldn't make any sense, right? People have directly calculated A dot dl. Simply they have taken this rim and they have calculated the answer. But sir, for this curved surface, how you can say this is the surface? How you can say this is the curve C, right? So every point should be clear, no? That if I am applying Stokes theorem, then how I am applying the Stokes theorem? How I am applying the Stokes theorem? For the Stokes theorem, I need the curve C, right? Closed curve C. How it is the closed curve C? That's the matter of concern, no? I hope you would have understood now. It was a very good discussion, right? Now let's solve this question. This question you solve. Del cross f dot ds, upper hemisphere, surface. This question have been asked. What you will do in the examination hall? Sir, del cross f dot ds, upper hemisphere, all these things. What I would do is that orientation is outward. It is given. What does that mean? Plus j cap I need to take. Okay. Plus j cap, all these things I need to take. So, sir, I would know that I will apply del cross f dot ds. So, sir, I will apply the Stokes theorem. Stokes theorem, you can say inverse Stokes theorem you are applying, right? So, Stokes theorem would say that f dot dl, closed line integral f dot dl, closed line integral f dot dl would be equivalent to this del cross f dot ds over the curve C. I am supposed to calculate f dot dl now. Okay. Now, what will be my dl? Sir, it will be a projection on xy plane. So, it will become a simple, sir, I should not say projection, it will be simply a rim of hemisphere. So, it will be simply a circle in xy plane. Circle in xy plane, which will become x square plus y square equals to 4. This is your x, this is your y. This circle will be nothing but x square plus y square equals to 4. Here I need to move on this circle. For the curve C, what is the value of x? X is 2 cos theta. What is the value of y? Y is 2 sin theta. Right, so I am supposed to calculate f dot dl. What is f? F is 2z I cap, 2z I cap plus x j cap plus 3y k cap dot dl. dl is dx I cap plus dy j cap, because I am moving in xy plane. So what answer I am getting? 2z dx. What answer you are getting is 2z dx plus 2z dx plus x dy. Same scenario again, the same scenario, plus x dy. 2z dx plus x dy. When you are moving on this line, what is the value of z? The value of z is 0, no? So this will be 0. Now on this curve x dy I need to calculate. X was 2 cos theta. X was 2 cos theta. X square plus y square equals to 4, right? X square plus y square equals to 4. X equals to 2 cos theta. Dx equals to 2 sin theta d theta with the negative sign. Y equals to 2 sin theta. Dy equals to 2 cos theta d theta. X is 2 cos theta and dy is 2 cos theta d theta. So 4 you can take common, and theta will be going from 0 to 2 pi. When you are moving on this line, theta will be going from 0 to 2 pi. 4 theta goes from 0 to 2 pi, cos square theta d theta. What is answer? Pi. So answer is 4 pi. That's the answer that we will be getting. Done? Say yes or no. Okay. 4 pi is the answer. And this was also a very good discussion. Okay. This was also a very good discussion. Usually aspirants are confused in this one. They don't even know what they are doing. Someone would say that r is not constant. So this was for the surface. X equals to r cos theta, y equals to r sin theta, because r and theta both are varying. So dx dy would be r dr d theta. But when you are on a line, x equals to a cos theta, y equals to a sin theta, only theta is varying. Right? Understandable? R is constant there. Okay, then I guess this much is enough for this lecture. Okay. Next we need to solve the problems only. Question we will solve. Like this was also a problem only. This was a gate PYQ. So with respect to problem only, we got a conclusion. So we will keep on solving the problems. Let's meet in the next lecture. There as well we will solve some questions. Okay. Thank you very much. Happy learning. You can like the session. Okay. Thank you.